So religion is defined as the belief and worship of a superhuman controlling power. So what I have is belief, but it's not a religion. I don't worship these
Yes, it
guys.
is.
They're not a
Yes, it is.
superpower. No. But if
Yeah.
you feel it is, it's fine. I don't care.
Okay.
All I know is nothing comes out of the world of flat Earth, but the heliocentric model produces all of these wonders.
Oh, we're
You're
going to
joking.
heliocentrism now. Wow, eh? Oh dear.
That is a proper belief system. No proof
That
of
is
anything.
religious beliefs, and heliocentrism is actually sun worship. It puts the
Sun
sun at
god,
the centre
isn't
of
it?
everything.
Yeah, Helios is the sun god. So that is a religious belief system.
Yep.
Okay.
So there you go. That's exactly what you're worshipping, sir.
All right, man. It's cool. If it's a religious belief system, I'm fine with that, man. As long as it provides models.
It's a
As long
dogma
as it
as well.
provides models.
Well, you see, it
that,
doesn't. You see, it doesn't. It provides it provides individual models that work as standalone models. But you try and combine those standalone models into a combined working model, and guess what? You're just as fucked as the flat Earth.
Nope. It works seamlessly well together.
No, it doesn't.
No, it doesn't.
Yes, it does.
No, it doesn't.
No, they don't.
You have not got a complete working model. You haven't got
do.
one.
You do not.
No, you don't.
You do not. You cannot
present it. Bring it forward.
Yeah.
And you know what?
It's not 100% accurate. If that's what you mean.
You rumpus and all them people will say the same. They will not back you up on that point.
So you do not have a working model. You claim you do, but you don't have one.
We do. It's not 100%, the standard model has its flaws, but it works, and we work with it to this very day, and we make inventions and discoveries using it. It works just fine for us. Nothing comes from flat Earth.
Again, that's your belief system.
That's cool. I don't care, man. My belief system is what you guys live in. So
no, we don't. You actually live on, for want of a better term, a flat Earth, but you just don't realize it.
That's fine, man.
You just deny.
I guess at the end of the day, reality is subjective. So if I believe I live within the heliocentric model that makes predictions that always turn out to be true, then that's fine. I don't care.
That doesn't work. A heliocentric model that doesn't work.
It works.
You have little pieces. Flaws, you have little pieces that work, but as a combined model, it doesn't work. So
it works just fine.
In your head, maybe.
Why don't you guys have a model yet, though, or like something?
Well, you don't have a model.
Like why isn't the flat Earth
you have little
invented
pieces
or created anything yet?
Yeah,
like why don't we have flat Earth technology?
Everything that has been created has been done on a flat Earth.
But everything that's created is always created by people that believe the Earth is a ball. Like, how come people that believe the Earth is flat don't create anything? Yeah, well, everything we use today.
How can you prove
everything we use today? Because they say.
How can you prove the claims
people
you're making?
That make these things say the Earth is a ball.
Like
they say it in their own words.
Tesla, did he believe the Earth was a ball?
Yep. Tesla was not a flat earther.
Don't think you're right there.
Tesla believed in the heliocentric model. He was not a flat earther.
I don't think you're right there.
All right, show me Tesla saying the Earth was flat.
He was an ether man, wasn't he?
Yeah. Newton was an ether man. But they all believe the Earth was a ball. Ether doesn't mean flat Earth.
Yeah, but Newton didn't want gravity ascribed to him.
He didn't want the cause of gravity.
He was dead against gravity. He was dead against. Well, gravity is an effect. Yeah. Gravity is an effect. It's not.
And Newton didn't know what the cause was. He didn't want to figure out what the theory behind it was. He just had a law for gravity. In science, your law is your observed phenomena. The theory would be the what causes it. Newton didn't have a cause. He didn't have a theory. He just has Newton's universal law of gravitation.
Well, that
But
he didn't want
Newton
that
believed in
ascribed.
the ether.
He didn't want that ascribed to him, though.
Yeah, he didn't want a cause of gravity ascribed to him.
So how can you ascribe something to somebody who didn't want it ascribed to them?
We don't. We only ascribe the effect. We don't ascribe the cause to Newton. There is no theory of gravity created by Isaac Newton, so there is no cause ascribed to him. But he described the effect. So there is a law of gravity ascribed to him, because laws speak about effects. He didn't want a cause for gravity ascribed to him. A cause.
Right,
Cause
so
and
he
effects
has
are
an
not the same.
effect of gravity.
Yes, which is what we see. Things falling down.
With things falling down. Yeah, exactly.
Mass attraction.
No, you can't say it's mass attracting mass, because that
Okay,
you're
cool.
now
Things
giving
falling
it.
down.
You're now
falling
giving it a cause.
Things falling down. Let's stick at things falling down if you want.
Things falling down, exactly. So Newton's observation was
Not
things
all
falling
things.
down.
Not all things. No.
Well, yeah, not all things. So you have now said that mass attracting mass is the cause which Newton ascribed to things falling down, which is incorrect.
Can we rephrase that into things moving in the vertical direction? Would everybody be happy with that?
No, I would not be happy with that.
Well, it would state that the up and down part of it, but negate the need for up and down, because it would just be on that vertical line in a direction along that vertical. Wouldn't you agree? Right?
No, I say mass attracts other mass towards its center.
Yeah, but you're now using a definition of gravity that was ascribed to as Newtonian gravity, and he never wanted that definition of mass attracting mass.
Yeah, that old
Mass
school
attracting
gravity.
mass is not a cause. That is just the effect we see. We see mass attracting mass.
No,
we don't know what causes that to happen.
The effect is things falling down.
Things falling down is mass attracting mass.
No,
it's the
it's
exact
not.
same
No,
thing.
it's not.
It is.
No, it's
It
not.
is.
According to you,
because
it
things
is.
fall towards Earth because they are attracted to it. Because
according
those
to
things
you.
are made of mass, and Earth
According
is
to
made of mass.
you.
So they attract each other.
According to you.
Yeah, according to me and most of the people that live on Earth.
But not according to Newton.
Not according to you. No,
not
according to Newton as well.
No, you just said Newton had the natural law. The natural law is the observation something falls down.
Mass attracts mass.
No, you cannot ascribe the mass attracting mass to the observation. It doesn't work like that.
What
it
is
doesn't
the
work
formula?
like that.
What is the formula for big G?
Who cares?
The formula says mass attracts mass.
Who cares?
It's Newton's formula, and his formula says mass attracts mass.
No.
Yes.
No. You said Newton made the observation. The natural law is the observation. The observation is things fall down.
And the observation is explained through an equation. The equation is Newton's universal law of gravitation. Within the equation,
Newton never wanted gravity ascribed to him.
No, he didn't want the cause of gravity ascribed to him. He
So
never
he
tried to figure out the cause, because he wanted to say that the cause is most likely God. You know, Newton was a very religious man.
Oh,
to him, the cause of gravity was God. Yes, Newton wrote more about theology and God than he did about science. Newton was crazy about God. So he never bothered with the cause for gravity.
So you've gone from mass attracting mass to a bendy space-time.
So mass attracting mass would be the effect we see. Bendy space-time would be the cause. But there are many causes.
Mass attracting mass cannot be the effect.
It is the effect. Newton's equation says that.
Oh dear. Double speaking everywhere.
I think it's needed to survive in the world Nate lives in. In order to survive in that world, you have to, I don't know, you have to believe.
You have to be a master of double speak.
Yeah, oxymoron central. Right, Nate. You like straight lines. You can imagine them horizontal, but then you can also imagine horizontal lines bending round a ball. You can imagine people using tools to measure this curvature when all of the tools measure straight lines and angles between straight lines and points.
And horizontals.
And horizontal, yeah.
There are no tools for measuring curved lines. No.
Mm?
There are no tools in surveying for measuring curved lines.
Don't they use protractors and compasses?
That's for measuring angles, and that's the angle between two straight lines.
Oh yeah, true. Yeah, I guess there are no tools for measuring curved lines. I don't know. I don't know, man. I just know they've measured Earth to be a ball. How they did it, I don't know.
No, they haven't.
But I believe them
It's
and I trust them.
It's never been measured.
Then you
mate.
need to go and tell them that they've never done it. I do not trust you. I do not believe you. I believe them and I trust them.
I don't need to go and tell surveyors that they've never measured the Earth as a
So
ball,
why are you
because I
telling me then?
I don't think it is. You're the one that has that belief system. You're
So
the one
why?
that should be
So
double
why are you
checking your belief
challenging me
system.
then? Like,
Dude,
why
I'm-
do
I'm-
you care what I believe in? Like, why do you
I don't
keep on
care.
telling me what I believe in
don't-
is wrong?
I don't care
Then
what
why?
you
Then why
believe.
do you say that? No, my belief is wrong. They're wrong. They never.
Well, your
measured
belief
it.
is wrong because
Why
water
do you care?
seeks and finds its own level. Well, you came here.
Why?
mate.
Why
you
can't I came
here
in to talk to Bev and we were just talking about levels.
to have
All
the
of a sudden,
discussion.
this has turned into a flat Earth, globe Earth discussion. I never made it that.
Well, to have the levels, you need a flat, horizontal surface. Water seeks and finds its own level. Level is a horizontal surface. The Earth is 7/10 water. Hey presto, you have a flat, level surface.
The Earth's surface, yeah. A lot of it is water, but
Yeah,
not
it's
the
flat
Earth
and
itself.
level. Flat and level.
Not flat.
Majority
No.
of it
But
is
yeah, clearly you're trying to
connected
make
as
this a
well.
flat Earth argument. To me,
Well-
the Earth is not flat, and beyond that, there's no point. You're discussing it.
The Earth isn't flat to me either.
All
There
right,
is
cool.
Local topography,
That's
which
fine.
dictates it cannot be flat.
That's
So,
cool, man.
so it's
The
basically
Earth
all
is
about
whatever you
water,
want.
isn't
Hang
it?
want it to
hang
be.
on, hang on. Spot on. Sorry, mate.
I mean, really, then the only point that matters is establishing whether or not water is level and horizontal straight line, because you confirmed that it doesn't matter what's going on below the water, but it does matter what's above the water.
No, it doesn't. Because water's the surface of water is not going to tell you the shape of the thing it's resting on.
No, yeah, I know, but water's established a straight line horizontal, isn't it? So everything
Water is
on-
established as level at its surface.
everything
yeah.
linked to that piece of water will be on the same level. And if all
On the
water
same
is
level,
linked
yeah.
to itself, then it
Yeah.
is level.
Yeah, it'll stay level. Water will be level
Nice one.
at its surface. Yeah. Oh, there we totally agree. We're on the same page. I'll never disagree with that. Water
Yeah.
at its surface remains level at rest.
It's
Nate,
just when
Nate was the one that told us about making the water level test into an experiment. You know, he was the one that gave us the idea. So
Oh, what
Yeah,
for
yeah,
lifting the middle bit up?
yeah.
Yeah, that was all me, man.
Yeah, nice one, mate.
Yeah. So that shows even on uneven topography, on an uneven surface, on an uneven ground, water at its surface will still stay level.
Yeah, sweet. That's what the test's
Sweet.
for, isn't it? We don't really need
Yeah.
to do
So
it, do we?
even if it's we don't need to do it because we all agree. If the floor is uneven, if the floor is a curve, if the floor is a triangle, water is going to stay level at its surface.
Yeah.
So we all agree, man. So there's no point.
Sweet.
Yeah.
Yeah, but the
There
thing
we
is-
all
the thing
agree.
is, though, what you don't, I don't know if you understand that. How can you not understand that if water is covering so much of the surface of an area, and it's all level, straight line, then where is the curvature?
Now all of a sudden you're adding extras.
Oh, am I?
Before
Sorry.
you were never saying straight line. Before we agreed,
Horizontal.
water
Yes, we said that
is
loads.
connected.
Horizontal, is
No,
it?
no,
Yeah.
no. Stop the drivel did not say straight line. He said water is level at its surface. All of this water that is connected will always stay level at its surface,
Yeah.
at rest, regardless of what it's resting on.
Yeah,
Oh,
you,
so you
you
so
said
you're saying
horizontal.
It's when you guys start adding horizontal at a
No,
point.
that was you.
That was
At a
you
point,
that said at a point.
Yeah, at a point.
But
Horizontal at a point.
horizontal is
You
not.
guys are saying horizontal
Hang
lines.
on.
That's something
Horizontal is
different.
not defined as being horizontal at a point. Horizontal is defined as being horizontal along the length of a line, and a line can be any length.
Horizontal is
from one
defined as
point to
being
another point.
parallel to the horizon. That's how horizontal
So
is
it's you,
defined.
Nate. It's actually you that's adding things to the definition to get what
No.
you need to happen.
So I'll
Yes.
reread what the constructors from the Organization of Engineers or whatever say.
Right.
Level surface is a continuous surface parallel to the mean spheroid of the Earth. The level surface is represented by the level line, right? The line
Right, this is
representing the level
just what
surface
this is
is
just what they
termed as
say.
level. Yeah, this is what they say, and I
This
believe
isn't
them.
definition. This isn't definitions of the
It's
individual
definition
words.
to me.
It's not.
It's
not.
from a
this-
quantity
this is-
surveying context.
This is
it's
terminology for
Quantity
the job
surveying,
that
sorry.
they do.
quantity geodesic. Yeah, from a surveyor's context.
Quantity surveyors survey quantities. If you want 10 pencils, quantity surveyors will get you 10 pencils.
Sorry, I
If-
meant
if you
doesn't
want a ton-
understand that. Yeah, it's quite, you should have left. You should have left him talking about that because that was brilliant.
Sorry, it was just doing
Yeah,
my head in.
thank you for correcting.
What
it's
did you
basically
mean?
Go on, sorry.
Yeah, what did you mean, Nate? If you got that wrong with quantity surveyors, what sort of surveys did you actually mean to add in?
Geodetic surveyors.
Yeah, that was the other one. There was another one as well. You didn't you? You had quantity
No,
surveyors and
what I was
geodetic
gonna say.
surveyors. So,
I was just gonna say quantity.
oh, just the one then? Like you just made another one up because
Because
so
it
it
sounds
sounded
good,
good.
if you
Yeah.
have two. Doesn't
did it sound impressive? Like did
Two
how many-
always sounds better.
Yeah, land surveyors, quantity surveyors.
land surveyors?
Land surveyors.
Right. Well, now see, land surveyors have a horizontal frame of reference. They survey on the plane.
Establish at a point. Yeah, they level one point to another.
On a plane.
On a plane surface.
Yeah.
Yeah. With
Yeah, they
So
draw a
the
line
different-
between those 2
is
points
it
to
just
level them out.
So it's the word straight, isn't it, that you're having a problem with?
It's the word flat that I'm having a problem with.
Who's used the
Flat.
Who's used that?
It's what you guys are trying to insinuate.
Plane.
No.
Yeah, but nobody's used it.
Plane. You
All
use
right,
plane.
So they level 2 points out by drawing a horizontal plane of reference between
Yeah,
those
plane.
2 points.
Is that a straight
You
line?
just said plane.
Okay,
Let me
a
get-
straight
let me
line
get that
between
one for
2
you.
points, even though those 2 points could be on a surface.
Hold on.
Yes.
So that's a straight line, yeah? And to establish that straight line, you could use a number of tools. One of them could be a water level.
Yes. And you would be able to establish that straight line even if we are standing on 2 points of a curved surface. Just like that image you posted. Stop the drivel. The
So
one
what
up there
happens?
with the checkered horizontal line and the green curved line underneath. Just like that. You and I are on 2 opposite sides of a curved hump, and we establish a level horizontal line between us.
But we've also established to put a canal between those 2 points, you have to dig down nearly 1,200 feet to get the surface of that water level.
Oh, do you have a read of that bit plane in geometry there? That'd be quite interesting, that, Nate, because
A plane is a flat surface that has no thickness. Plane contains many lines and extends without end in the direction of this line. It can name a plane by the single capital letter by at least 3 of its non-collinear points.
Right, and the last bit that. See in that
Yeah.
in the first bit, when working exclusively in a two-dimensional Euclidean space, the definite article is used. So the plane refers to the whole space. Many fundamental tasks in mathematics, geometry, trigonometry, graph theory, and graphing are performed in a two-dimensional space, or, in other words, in the plane. So nobody has to use the word flat because we're talking mathematically. Like, you trust mathematics, don't you? I mean, that's where you get your proofs from, right? Maths and geometry, when that's how they use plane. And you used it. The water level is a horizontal plane. You said it, didn't you?
Horizontal plane of reference, yes. At a point.
No. Like, read the definition of plane again, because that's the definition you're using, isn't it? You can't have a plane at a point.
At a point.
Do you know?
From
It
that
doesn't
point,
say. It doesn't say
I
at a
generate
point.
my plane.
Do you want me
Why?
to?
Why are you adding at a point?
Can we
It doesn't
do
say at
definition of a point?
Because I want to. Why not?
Nate, what's a point?
Because you need to.
Maybe I
Not
need
with-
to.
You
Does it
need
matter?
to.
Does it matter?
Well, if we're talking about proofs, and you need to add something
I'm
to
not
get
trying to
your
provide
proof.
proof for a
Well,
globe.
we're talking about definitions. And definitions are proofs.
I'm not trying to.
And
prove
you're
anything to you.
needing to add the word at a point, or the phrase
I'm
at
not
a
trying
point,
I'm not trying to define what a plane is.
to define your proof of
You're
a
not
globe.
trying to define.
I'm not
what
trying
a
to
point
define my proof of a globe.
Is. What
I'm
is a
not
point?
trying
So
to
why are
define
you
what a
adding?
plane
Why are
is.
you adding at
Dev
a point?
is the one.
Why are you adding at a point?
That's not the definition for a plane. I'm not defining a plane. I'm
Well,
saying
stop. Why are you adding at a point? Stop adding
I'm
at
saying
a point
water.
because it's not in the definition. You are just adding those words to make
All right.
yourself feel better. So stop doing it because it's not in the definition and it's
Okay,
not needed.
Yeah, all right, I agree with you. That isn't the definition of a plane. But
Right,
this is
so
what
stop.
I will say.
Stop adding.
I won't add it to the definition of a plane. Cool. This is what I will say. Water will be level between two different points at its surface, regardless of what it's resting on. Water being level at two different points can be used as a horizontal plane of reference at those specific points. That's all I'll
No,
say.
so you've
This
added it again. You've
doesn't-
added.
this does-
You've
Yes.
just said at specific points.
Yeah,
But
that
but
is
that's
not me
in the- that's not
defining
in the-
what a plane is.
That's
I'm
not in
not
the
defining
definition.
what a plane is, though. I'm not defining what a plane is.
But you're adding what you
At
need.
a point, yes, I can
You
add
are-
at a point because I'm
There
not
you go. I
defining
can
what a
give
plane
you
is.
the definition. It's book 1, definitions, Euclid's Elements, the book
Yeah.
for geometry. Point 1 is the definition of a point. Now read it,
Yeah,
because
Point
this
that
is
which
what
is
you're
the part
saying a
or which
plane
has no
is.
magnitude. It's not what I'm saying a plane
Yeah, it
is
is.
at all. No, it's not. I never said this is what a plane
You
is.
said a horizontal
I'll say it
line is
again.
only horizontal at.
I did not say that. That's
Oh,
lie. I never said
okay.
it's only horizontal at. Now you're
At a
lying.
point. You
So
did.
I'm going to say it.
Well, you say at
I'm going
a
to
point.
say it for the last time.
hmm
All right? Please follow me now. Water will be level at its surface at different points, regardless of whatever the water is resting on. So,
No.
because water is level at these different points, we can use
Why are
these
you
different
adding
points
at
to create.
that different points?
What is a point
It's
again,
Because
Nate?
water is level at different points, is it?
Well, what
It's
is a
level
point?
along its length.
So at different points, it is still level. So because it's level at different points, I can connect those points
At
with the
different places
horizontal
that
frame
don't
of reference
exist, right?
at
Yeah.
those points.
Yeah. The point is that which has no parts.
I'm not saying the point has parts. I never said it does.
But how can you have a plane at that point and that point only when that point has no
I
parts?
never said
Has no
you
path.
can have a. I never said you can have a point at. I never said you can have a plane at that point and that point only.
But a point
Those
has
words
no
never
path.
left my mouth. I never said points of
Is a
paths.
point a position?
Yeah, you could say it's one fixed location, just a dot.
It's no.
It could be a point on a line, or a point in in space and time. It has no magnitude, no parts. It's just
It's nothing, right?
yeah, it's nothing. It's just a point. It's just a position.
Zero-dimensional thing.
Yeah.
Whereas a line, right?
It's one dimension.
Is yeah. Can you explain that?
Because it has magnitude and direction. Now it has a vector, either along an x, y, or z axis in space.
So if you put the pen to paper, as soon as you go to move it, you've
created a vector.
If I join two vectors, I'm in 2 dimensions because I have height and width. If I join a third one, I'm in 3 dimensions because I have height, width, and breadth, x, y, and z. I mean, these are things we agree on. It's just you guys are trying to be weird and trying to say things I didn't say and use that as a got
No,
you.
hang on. You're the one that's adding things to definitions. So
I'm not adding anything to definitions.
Yeah,
I have
you
not
said at a
defined
point.
anything.
You have said many times.
When I said at a point,
point,
what was I defining? Tell me what it is I
you
was
were
defining.
trying to define a level,
Yes.
but a level
That's
is
what I was
level
trying to
along.
define.
Hang on. A level.
I
A
wasn't
level is
defining a point
level.
or a point. I was
A
defining level.
level is
Thank
level
you.
along its length, not at a point. Nowhere does it say it's level at a point.
Yeah, that's a good point, mate. To the pun.
So you are adding words to a definition to suit your narrative.
The level line makes right angles to the vertical line or plumb line at any point. It means that any point on the level line is equidistant from the center of Earth.
No. That is saying that. Read
That's
that
saying
again.
exactly.
Read that again.
Okay. The level line makes right angles to the vertical line or the plumb line at any point.
Right. So
It means
the
that
right
it
angle
means
can
that
be
at any
made.
point. Wait, but there's a second part
It means
to it.
that the right angle can be
But
made
it's
at
not,
any
it's not,
point
that's not all of it.
along
But that's not
the
all of it.
level
Yeah,
line, the
perpendicular.
horizontal line.
You can make it
Well, but that's not all
perpendicular
of it.
anywhere along
At
it.
any point.
Yeah.
At any point, yes. It means that at any point on the line is it means any point on the level line
a perpendicular
is
can
equidistant from
be
the center
made.
of the Earth.
No, it doesn't mean that at all.
It's what the sentence says.
No,
from the
it's not.
surveyors that I trust. That's exactly what the sentence says from the geodesic and land surveyors that I trust.
Oh dear, oh dear.
Yep.
You are clutching at straws, my man.
I'm not, man.
Yeah, you
That's
are.
what they say. They provided me with their proof, so I trust them. You guys haven't provided me with
Their
anything,
proof.
so I
Is
don't
that
trust
their
you.
proof that they wrote it down on the front of a website?
That and
Oh,
all of the other things that they've done, the things they've built with this understanding.
But you've not actually gone into the geometry and proved any of that stuff that they have.
I haven't, and I'm not going to
No.
do that right now. Like it's
But-
almost 6.
So would you trust somebody that had done the geometry to be able
Yes.
to say,
I would
That's
trust
impossible.
them. And they've done the geometry.
no,
So I
there's
trust
no geometry to support the curve? That's the point what we're trying to get to here. Because
There is.
surveyors, land surveyors, plane surveyors, the people with the tools, measure the land
Geodetic
using
surveyors.
Euclidean geometry. And as such, there is only supporting evidence for proofs in reality to support Euclidean geometry.
I don't know about all that, man.
No.
Because this is
It's
what
all- it's
civil
obvious you
engineers
don't.
are saying. Yeah. Well, if the civil engineers say it, I'm going to trust the civil engineers.
They mean they wrote
I'm
it
not
down
gonna
on a
trust that.
website.
They wrote it down, and this website has all of your geometry.
Okay, so
and stuff. I
who
just don't
do you
understand
think
it,
wrote
but I
that on the website? The website builder or
Yeah, under the civil engineer's instruction, because I'm sure that the engineers wouldn't want them putting things on here that they don't agree with.
right? So
Right.
that's what you're citing as your main reference for knowing that
For your
water
belief.
level can curve around a sphere whilst knowing that the water level is a horizontal plane
Of reference.
of
At a
reference.
specific point. Yes.
Yeah, sweet.
At a specific point. Yes.
So-
Yep.
Did you post
You do
that thing
realise
so
that's
we
a-
can go to them and have a word with them about this? And let them
Oh
know?
yeah, the link is there, man.
Yeah,
I
sweet.
posted the link as well. You can click on it and go and talk to them.
I don't know if you realise, but what he's just agreed to, he literally violates the law of non-contradiction.
Yeah, of
He
course.
can't
He's been
hold-
doing it all morning, Tony.
Yeah.
He's
Tony,
full of it.
Yeah, yeah. We've been round and round in circles with this one.
This
for
is
the
a
last 2 hours.
masterclass of
Yeah.
cognitive
no.
dissonance. Like,
And circle jerking.
yeah,
Oh no.
yeah, Nate.
Yeah. Okay. I don't care, man. I'm not trying to prove to you guys what the shape of the Earth is.
No,
That's not
neither are
the
we. We're not-
discussion.
don't
Oh
need
no,
to.
but you guys are. You guys are definitely trying
No,
to tell
we've
me.
just been talking
that I'm
about the
wrong
water level
or
being
believe-
horizontal.
Oh, you have. Stop trying to be innocent about it. You know,
No,
play
we don't
cool.
care. We don't care what you believe.
You don't care.
But
Oh, cool.
your
fine.
belief
That
your
is
belief
fine.
system is wrong, but we don't
All
care
right.
what you believe.
Fine.
So
All right.
we're not
it's
trying
wrong
to tell you,
you.
not trying to tell you anything.
All right. If you feel it's wrong, that's okay, man.
Fields. He's big on Fields,
Yeah.
DP, aren't you? Hits him
I am.
hard.
Fields.
Fields.
Yeah.
Feels.
Feels.
You
Yeah.
guys feel it's wrong, so it's okay.
Which,
All I'm
no,
saying is the heliocentric.
we're not the
model
ones that had
produces
to add
all of these
definitions for them to
wonders.
fit our narratives, are we?
I'm not changing definitions of anything. I wasn't
Well,
defining
you
points
you
or
added
planes.
to a
I was
point
defining level.
at a point.
You guys were the ones that are talking about planes and points. I was defining
No,
level the whole
no,
time.
no,
And then all of a sudden, you guys start
no,
talking about planes and points and
no,
what their
you
definitions
you
are.
were the one that added at a point to all of your
Because
definitions.
that is what leveling is.
No, it's
And I've
not.
read to you where I
No,
got
it's
that
not.
definition from.
Yeah, you
that
got it from a
definition
surveyor's
from
website.
civil-
That's not
yeah,
that's not a
created
definition,
by
is it?
civil engineers.
It's not a
If
definition,
you
is
aren't
it?
happy with how they define
It's
it,
not a definition
you
of
should
the
go and talk to
words,
them.
is it? I'm not going to go and talk to them because I don't really care. But it's not a definition of the words that you've used, is it? It's
a
just a-
definition of
It's
the
just a
term leveling.
citation from a surveyor's website. You're not using definitions. You are just reading
Right.
spiel from a surveyor's website.
Okay.
Yeah, there's no definitions. You've just added the words that you need to fit your narrative. That's all you've done.
All right, man. All I will say is, all these magical wonders we see in the world, all this technology was created by people that believe the Earth is a sphere.
And that's what you believe.
People that
Again,
believe the
this
Earth
is
is flat
this is your belief
don't
system.
create anything.
This, yeah, really,
Really.
really.
Maybe
how-
an
wait a
invention
minute, so
made by someone
it-
that believed the Earth was
Sorry,
flat.
people's
I'll wait.
beliefs matter to you, Nate.
Well, beliefs matter to everyone. We all have our beliefs because we all don't know
Yeah,
everything.
individuals' beliefs. I mean, but why should that matter about inventions or anything? You know, like why particularly?
Because they took that belief structure into their invention.
What?
Yep.
How, go on. Please,
For example,
please
if
explain.
I
how
was
you-
trying to send rockets into the air, I would send rockets into the air on the belief that the standard model works and the heliocentric model works.
Oh, that's
So I
interesting.
would take
that.
that
Interesting.
modeling into what it is I'm building.
So, do you believe that the rockets are going into the impossible place?
I do believe that, yes.
Yeah,
'Cause
and
I'm
does
not on
it-
the rockets, so I haven't gone there myself, but I do believe that is what is happening.
So, does it upset you that I don't believe?
No,
that
it doesn't.
rockets don't go into the impossible
I'm
place?
indifferent.
But
I'm
but
indifferent
also
towards what you
you see,
believe in.
But I've got this water level test, haven't I? Now,
You
does
do.
my belief in the impossible space vacuum, or the non-belief in the impossible space vacuum, affect my water level test in reality?
I no, it doesn't. Not at all.
So beliefs don't
'Cause-
matter then.
when it comes to that situation, no. Your belief in space won't determine water being level on Earth's surface.
Okay. So, how does somebody's belief system affect them being able to invent the computer, for instance, the telephone, as another, for instance, or the microwave oven, the internal combustion engine, being able to
Sliced
invent
bread.
formulas, sliced bread. Well
Yeah,
done.
sliced
thank
bread.
you.
The wheel. What about that? The wheel.
The wheel.
Yeah. What about
How does somebody's belief system stop them from being able to invent these things? And why does their belief system matter to anybody else who benefits from them inventing whatever it is they've invented?
Well, I guess, yeah, maybe not
Well, why
every.
does it matter? Answer that
Yeah.
simple question. Why does it matter? And to further that question,
Oh
why
my
do you
God.
bring it up?
I brought it up because I wanted to. It
And
matters to
okay.
me.
And why does it
Because-
matter?
It matters to me because it shows
It doesn't show
that-
anything. It doesn't show anything, does it?
to
though?
me, maybe not to you, but to me, it shows that the idea that the Earth is a sphere is more beneficial to my life because it'll help me understand reality better. It'll help me produce more in the world, and it is more than likely that that is what Earth is.
Absolute bunk. Absolute bullshit.
All right, man. If you
Every
don't
word
agree
that
with
just
it,
came
that's
out of your
fine.
mouth is just
Yeah,
absolute
if you
tripe.
don't need to agree with anything I say. You don't need
Oh,
to like
dear.
it. You don't need to believe it.
No, I think it's hysterical.
Don't care.
I think it's funny.
Yeah, you can find it funny. I really don't care, man. All I'm saying is, people that believe the Earth is flat don't invent anything.
Yeah, but that is your belief. You can't know
Then
that
show
as
me
a fact.
something invented by someone that believes the Earth is flat.
Okay, you show me something not invented by someone who believes. Your reasoning is
Computers.
pathetic.
Computers were created by someone that did not believe the Earth is flat.
And how do you know that? How do you know everybody's belief system?
Well, not
You-
everyone,
you were
but,
just
the major
assuming.
people,
You were just assuming.
the major inventors. Yeah,
you're just
Einstein didn't
assuming.
believe the Earth was flat.
You were
Newton
just
didn't believe it
assuming.
was flat.
You're just
Tesla didn't
assuming.
believe it was flat.
You were just assuming.
You know?
You don't know these individual people's belief systems
Well,
to be able to say
they've
that with
written,
100%
they've written about
certitude.
it, so I trust what they wrote. They've spoken about it, so I trust what they say. Right? Newton used planets' orbits and the Earth's orbits to prove the heliocentric model and gravity. He therefore believed in the heliocentric model.
Sorry.
He wrote about it and spoke about it. So therefore, I'm going to assume, obviously, that Newton believed Earth is a sphere. Come on, man.
So how can you say with 100% certitude that these things weren't written about after him and attributed to him? You can't.
We do know that Newton said, "Do not ascribe gravitation to me."
Yeah,
You
we've
are
been
aware.
through this one. Yeah, we've been through this one with him,
not
Tony.
ascribe the cause of gravity to me. Yeah, he did say that. That is a good question. How do I know for sure, 100%, that 100 years after Newton died, someone didn't just write that Newton did this? Well, that would be a very hard thing to fake, you know?
No, it wouldn't. All you got to do is write some words in a book and say Newton said this.
Yeah, but then you would need everyone over a period of 300 years
No, you
to
wouldn't.
agree with that. Yes, you would.
No, you wouldn't. No, you wouldn't. You can
Newton lived
change. You can
300
change.
years ago.
You can change a
between
pop.
300 years and today, you got to ensure that no one writes anything saying that it was Newton or that it wasn't Newton or
You
that
can change a
no one writes
population's
something
way of thinking
contradicting
in
that.
2 generations. It only takes 2 generations to change a population's way of thinking.
And we can see proof of that right
That's
now. If you look at the North American oil fields, they're all filling back up again with crude oil, but they're not supposed to be filling back up. But in 2 or 3 generations' time, when they're full again, they can start extracting from it, and nobody will ever remember that they're a fossil fuel that was drained and will never replenish. They'll be representing it as a brand new oil field. Literally, look it up.
I don't know. But all I'm saying is, it is very difficult to falsify history.
Do you know what you're saying? You
to the extent where you have
all I've
no.
all I've heard you say, right? When we
you-
bring things
Dude,
to
you also gotta not interrupt me, man. You know. So all I would say is I've never read anything that says it wasn't Isaac Newton that came up with the
well,
universal law for gravitation.
if it's
I have never
ascribed
seen
to him,
anything to the
if it's
contrary.
if it's ascribed to him, you won't, will you?
Not
Because
even just ascribe to him. There are books
they
that
won't
he
say
wrote
that
that
they
I
won't
read.
say that we
right?
wrote this book in Isaac Newton's name, but he didn't actually write it, even though we're saying that he did. You won't
All right.
ever find that, will you?
Yeah, but if I wanted to look into history and figure out is it a lie that Isaac Newton came up with the theory of gravity, I would look for writing that is
How
to
about a
the
quote
contrary.
that says, "Please
Yeah,
don't
I would look
ascribe
for,
this to me"?
yeah, the quote says, "Don't
With-
ascribe the cause of gravity to me, not the effect that we see, but the cause," because he believes the cause of gravity is God. He believes it's some mythical figure that causes mass to attract mass. His equation says mass attracts mass. That's the equation he wrote down. It is the effect, Newton's universal law of gravitation, not his theory.
Newton's equation didn't have the G in it. That was put in 100 years after he died.
G equals mass of one body, mass times mass of two body, R. The radius of them, the centers of their mass.
Yeah, but Newton's
inverse
equation,
to the distance between them equals G.
You just cited Newton's equation, right? But
Yeah.
Newton's equation is not FG equals M1. It's literally F equals M1, not FG. The G bit was added 100 years after he died.
Which is exactly what I've just said about things being added and ascribed to somebody years after they die, which changes the paradigm. It changes every generation's way of thinking after that was just like the G was ascribed to Newton 100 years after he died. So every generation after that 100-year point has now got a different way of thinking.
I so don't understand what you're saying. You're saying Newton's original formula was F equals M1 times
Yes.
M2 over R squared.
Yes.
But where is the gravitational constant that Newton discovered then?
Newton didn't discover a gravitational constant.
He did.
He didn't believe there was one.
That is the universal law of gravitation.
No, that came
Big
100
G.
years later.
No,
Yeah,
small. What?
Look, let Tony
Right.
speak. You had a go at me
Okay,
for speaking over
go
you,
ahead,
so
go ahead.
let
So
Tony
sorry.
speak.
The best way for me to do this, because it's quite a lengthy explanation, and I'm not versed on the bit where Newton put everything after, because like somebody's done it afterwards. What I'm going to do, I'm going to refer you to a video that explains it in detail, and he gives all the citations, so you can check every single one of them yourself, and you can see whether or not he's lying or misrepresenting or cherry picking, and then you can come back and you can say, do you know what? Maybe it was put in 100 years after Newton died. But just bear with me 1 second while I find it.
All right, that's fair. Yeah, let me watch the video.
Yeah.
And then go and verify it myself because this is new to me. This is all new to me.
Right,
I didn't, this whole 100 years after, I've never heard that before. If you're talking about small G,
would you agree that, given that you've never heard it before, would you agree that if it is true that it was added 100 years afterwards, then would you agree that it does change the way you perceive what you think you knew before?
Definitely, because I did not know this before, so it'll change everything.
Shit.
Did you hear what I said?
Yeah, it changes everything. What I'm going to do, I'm going to put it in the side chat for a minute. Because I think that's the video. I'm just going to go and find.
I think for Nate to see it. Sorry, Tony. For Nate to see it, you need to put it in the live stream chat.
Okay.
Put it in the side chats. Side chats only for us.
Okay. I think that's the video, and I think I'm just going to skim through it, and hopefully he has it on screen.
Yeah, it's quite a good source.
Flat Earth debate. Gravity is not a force. Oh, a QE debate. This is so biased, man.
It's not a debate. It's a one-sided explanation of the contradictions of gravity according to Einstein over Newton. Now, even
From
if
QE?
again, this goes back to the position that even if you think that gravity is a force, it isn't actually a force. The current physics states that it's an effect. You are aware of that, right?
Sorry, could you say that again?
Even if you think that gravity is a force, the current
Mhm.
position in physics is that gravity is an effect. It's not a force, it's an effect. For it to be a force, it would need to be a cause, but it's not, is it? In Einsteinian gravity, since
That
1915.
makes no sense, man.
I agree it makes no sense, but that is the position in current
No,
physics.
the way you are explaining it makes no sense because it's not right. When
Well, how
Newton
would an effect?
created Big G, he saw gravity as a force. He doesn't know what causes the force. He just knows the effect of the force. What is the effect
Sure.
of all forces? They move matter. That is the effect. We see
No,
matter
the
move
effect doesn't.
towards
No.
other matter.
No. Forgive me.
We see
You just
mass
said
attracted to mass.
you said the effect causes masses to move or whatever.
That is
you
the
just
effect
said.
of forces, right? It
The
makes
effect
mass
of
move.
forces is an acceleration, yes,
The
but gravity is
acceleration of
not.
mass. Gravity
Gravity is not
accelerates
current.
mass.
Nate,
Newton saw.
Yeah.
let
Oh,
Tony
sorry.
give his explanation.
Come on.
You keep talking over him.
All right,
So
sorry, my bad.
if there's a force applied to an object and it moves, you need the force, and the effect would be that it accelerates. But without the force, there can't be an acceleration. Now, Einstein in 1915 superseded Newton. He replaced Newton. He totally changed the way we think about gravity. He removed it from being on the XYZ coordinates to the XYZ plus time. So he's added a completely new dimension to what was previously a three-dimensional, like Cartesian-based system, to a four-dimensional pseudo-Riemannian force space. But the key word is pseudo being not real. Now, when he creates this pseudo-Riemannian force space, he mathematically calculates it all out so that it all makes sense. Nobody can understand any of the maths. We all believe that it works, and we're told that it reduces down to Newtonian principles, and they are basically the same. Now, the problem is, Newton's not the current physics, Einstein is. But the problem with that is, Einstein describes gravity as the effect, which would be the thing accelerating, not the thing that's pushing it or the thing that's pulling it. It would be the rate of acceleration because that's the effect. But we're asking, well, what makes Newton's apple fall from the tree then? Because Newton's apple falls from the tree and it starts to accelerate. We see the acceleration, that would be the gravity, according to Einstein. But we want to know what pulls it or what pushes it. Now, Newton's argument or Newtonian gravity would be the Earth's mass is attracting it. Well, we think that's nonsense because we don't think that gravity even exists. And if it does, it can't be demonstrated. But Einstein says, well, it's the uneven distribution of mass that causes the curvature of space-time. And what that does is that's what makes the apple move. And we just think that that's gobbledygook. But it leaves the question, what is gravity? And it's an effect by current physics. So what we're asking is, how do you get the acceleration of any object without applying a force? Because Newton's first law of motion states that F equals ma, you need a force. Well, you can't have an acceleration without a force. And if gravity is the acceleration afterwards, the effect, then what's making it? Do you know the answer?
A lot of what you said is wrong, man. Newton's first law isn't F equal ma. That's the second law. Newton's law of gravitation works on 3 planes, x, y, and z coordinates, not 2. Einstein's works on 3.5 because he adds a temporal dimension.
No.
Newton's.
Right.
Oh, come on! Don't interrupt me. Don't interrupt me. I let you talk.
You've just corrected two things about what I said that were both wrong. The first thing, Newton's first law is the mathematical representation of his second law, and I correctly cited that F equals ma is the first law. So let's be clear.
Law.
F equals ma. The
second law of motion.
The second law describes for every action there is the second
law
that's
the third law.
An object in motion will remain in motion unless acted upon by
that's
force.
The first law.
No, one of them is a mathematical representation. The other one's done by
the
words.
Second law is the mathematical representation. F equals ma is the second law.
Forgive me, I've got it the opposite way around. But
all right, cool. Yeah, I was just correcting you.
Okay, I'll accept that correction. But I said X, Y, Z was Newton, and then I said Einstein added time. But I said it was only in two dimensions. That's incorrect. I said that Newton's was x, y, z, and Einstein's is x, y, z plus time, and it's a totally different coordinate system.
Newton's system was on 3 dimensions, x, y, and z. 3
Correct.
spatial dimensions. You're saying it's only x, y. Einstein's
No,
was
I'm not.
x, y, z
I'm not.
plus time.
No, I'm saying it's x,
But
y,
you
z.
said you didn't say z. This is the first time you're saying z.
I did. I said x, y, z for Newton and x, y, z plus time for Einstein. That's what I said.
You said x, y, man. But it's cool. Fine.
Didn't.
Okay.
Didn't.
All right.
So what makes Newton's apple fall?
The force of
I can
gravity.
explain it. I can explain it very easily. I can say that the tree gave it nutrients, that gave it mass. The more nutrients it gave, it increased its mass. Eventually, it snaps the stalk, and because it's more dense than the medium it's sat in, it displaces its medium. If it was growing underwater and the apple snapped off the tree, it wouldn't fall to the ground anymore. It would fall to the sky or to the top of the water. That would be because the apple is less dense than the medium it's growing in, and that denotes the direction and the magnitude that it travels. I can explain that completely with relative density, but you can't explain that with gravity because gravity is not a force. It doesn't make anything move.
I can.
He just said it was gravity. He just said it was
I'm
gravity
telling
that
you,
makes it
it's
fall.
I can explain it with Newtonian gravity. I can explain it with Einstein space-time. I can explain how gravity is still in play underwater due to the buoyancy force. We all have our explanations.
Right, you're scattergunning, right? So you've just said that you can explain it with Newton. You can explain it with Newton, so can we all, but that's not the current physics. I don't think you can explain it with Einstein. I want you to do that in a minute. But when you said about the buoyant force is dependent on gravity being a force and applying Newtonian physics. You can't apply Einsteinian physics when you're talking about buoyancy, because buoyancy is Newtonian and that's been superseded by Einstein. So you can't talk about buoyancy. You've got to talk about bendy space-time. So do me a favor, just answer the question, how does Newton's apple fall applying current physics known as Einsteinian gravity, please?
So how does Newton's apple fall due to space-time curvature?
Yes.
Okay, so what happens is Einstein has 2 theories, right? He has special relativity and general relativity. General relativity tells us that space and time are the same thing. Special relativity tells us that mass and energy are the same thing. When you combine them together, it says that when you add mass or energy into a gravitational field within space, it'll change the rate, or not it'll change, it'll affect the rate of change or time within that gravitational field. And thus change the effect of time on the energy or matter within that field. So we have an apple, which is mass. We add an apple to a gravitational field, it creates gravity. Now, the thing is, an apple is already within Earth's gravitational field. So within Earth's gravitational field, we see that the more mass or energy Earth has, the stronger Earth's rate of change on space, which is exhibited through time. And we see this happen within geodesics. So we see everything move within a geodesic, within a geodesic, what's the word to use, man? Vector of direction, for lack of a better term. It moves within a circle, So that's what happens to space. It is bent by matter and energy, causing things to move within a geodesic. So when an apple is falling, it is falling in a geodesic around Earth. But because it is too close to Earth's surface, it hits the surface. You need to remember that the apple is falling in a geodesic around the center of Earth, because that is where the center of mass is. That is what is causing the curvature of time, Earth's surface. But not Earth's surface, Earth's center. But because the apple is too close to Earth's surface, it cannot obtain perfect freefall. It cannot obtain that perfect geodesic, so it hits Earth's surface as it's falling in its geodesic around the center of Earth. That is what's happening with space-time and apples falling.
So what you've just described, I'm going to describe as poetry because it sounds beautiful.
That's
you
fine.
You did really well there, I'll be honest.
You don't need to believe it.
Best. What?
You don't need to believe it. You know, that's just
No,
how
no.
I understand.
No, this is not about belief. Well, I'm
Okay.
going to credit you with probably the best recite of an Einsteinian explanation for Newton's apple I've ever heard. That was beautiful, man. Really, really good.
Thank
The
you.
problem we've got is science is defined. We know what science is. It is the study of the physical and the natural world through observation and experiment.
Mhm.
In your explanation, your eloquent, beautiful explanation, and I'll not challenge any of it. I'll just accept that everything that you said was right. It isn't capable of experimental application. So therefore, it falls outside of the definition of science into the definition of pseudoscience. Whereas mine, when I said about the nutrients filling up the apple and giving it more mass and then it dropping because of the medium it's in relative to the mass of it, that does have experimental application. But that would mean that mine's within scientific method and therefore science. So what I would pose to you is that perhaps you're falling for pseudoscience in substitution for actual science.
Okay. I like what you said, and it sets me up for a good response. So you define science, you know, I agree with your definition. It involves understanding the natural world through experimentation and observation. That is very key, observation. So yes, it is very difficult for us to experiment with space-time because we cannot create objects massive enough for us to see the curvature of space-time ourselves. But if we look out into deep space, we can observe it happening. And as you said, observations are part of science. So when we look into deep space, for example, the eclipse of 1919, when we look at the sun during a solar eclipse, right, and we see light from a star behind the sun curve around the sun, that is proof of mass-bending spacetime. When we look into deep space and we see Einstein rings, we see light traveling from distant galaxies turn into circles because the space-time they are traveling through starts getting bent into geodesics by something with a lot of mass being in the way, either dark matter
just
or
a minute.
black hole.
Before you keep saying that.
No, let me finish, please.
No, you
That
keep
is
saying
an
it keeps getting
observation.
bent to geodesics. If you're talking about special relativity, have a look at the bit that I've just put in the chat. Right? Because the geodesics that you're talking about in special relativity are straight lines.
On curved surfaces, yes.
No.
It's a straight line.
In Minkowski space.
Which has been,
they are straight lines. They are mathematical concepts.
Yeah, it's a mathematical concept.
Yeah.
It's a straight line on a curved surface.
No, it's just a straight line
and
on within a
Einstein
space.
Rings have been observed. Light traveling from distant stars around the sun during a solar eclipse have been observed. This is what turned Einstein's hypothesis of general and special.
You're talking about special relativity or observations looking out at the lights in the sky. You're getting mixed up, I think.
Observations.
Right, well, that's not special relativity, is it?
Theories of special relativity and general relativity. It is. Einstein predicted light can travel on a curved path if the path it's traveling on is bent by matter. And we've observed that.
But that bent is actually a straight line, right?
It's a straight line traveling along a bent surface. And that is a geodesic.
It's a straight line traveling on a bent surface in
a curved surface. Space and time.
With time, yeah. That's a mathematical concept, right?
Yeah, and
so
using
it's not,
that mathematical concept,
observed. Okay.
It's been observed. We've observed Einstein rings. And using that mathematical concept, I can make predictions in the future that turn out to be true.
You can make predictions.
People can, yeah. I can as well. But that's some difficult math, which I'm not going to do now. But people can.
Your maths isn't very good, mate. Come on.
Yeah, it's probably a good job. Good job you're not going to do it now. Because you'd only get it wrong.
Okay, I most likely wouldn't be 100% accurate. You know, it's a lot of calculus and stuff I would have to do. But
and you can't be bothered to get a calculator.
No, I said calculus.
Yeah, and you can't be bothered to get the calculator. You proved that point
I
earlier.
wouldn't use a calculator to do calculus.
Oh, okay.
Nice.
Yeah.
You do it in your head, yeah?
Yeah, I would have to take out a pen and paper. I mean, I don't. My calculator is a scientific one. It's not an engineer's calculator. I can't put in functions into my calculator.
All right, I'll just have to take you at your word.
An engineer's
Belief system.
No, but I mean that's how calculus works with functions. You guys have done calculus, right?
All right.
Okay, never mind.
Yeah, but I don't know what calculator you've got, do I? I'll just
Yeah,
to
I have a
take you-
normal, simple scientific calculator.
Okay,
I
it
cannot
doesn't
put
matter.
functions
Doesn't matter.
into it. Yeah.
It's
I don't
neither
have-
here nor there, is it?
Have you guys seen those big calculators that engineers use, where you can even draw graphs on them?
Hang on,
That's
you're
what I
getting
was-
away from the point that Bev was making.
I don't know the point Bev was making, but I was trying to address what the other dude said.
Yeah,
Because
let me
the
respond to that.
other dude said that gravity falls into pseudoscience, or space-time falls into special and general relativity fall into pseudoscience.
Okay,
Mechanics.
so
Fair.
let me respond to that.
But I'm telling
Let me
him that we have
respond
opposite. Oh, okay. Go ahead.
Okay, so you said that basically what you said was, but when we look out into the distant galaxies, we can see starlight coming from behind the sun. The problem you've got with that is you're only taking the word observation and you're ignoring the word experiment, because there is no experimental application to any part of Einsteinian gravitation.
But we have observations, and observations are part of science.
Yeah, but
As you
the
said yourself.
no. Observations. Forgive me. Observations are part of science, but they are not the only part. There is a secondary part called experiment.
Yeah,
Now, cited-
but if you don't need both of them.
Let Tony finish.
Yeah, you do need both of them. I'll just get you the citation for it. But whilst I'm getting that, look at Max Planck's definition of science. He said, or not. Look at his quote. He says, "Experiment is the only means of knowledge at our disposal. Everything else is just poetry, imagination." Now, I tend to agree with that, because when you're fantasizing over applying Einsteinian gravitation over a long distance with starlights from behind galaxies that we believe are millions of light years away, you are going into the dreamy world of pseudoscience. Now, I'm all right with you being there, provided you don't try telling me that that's science, because it isn't. It requires experiment. So bear with me while I get you the definition, or get a definition. All I'm typing in is science definition on Google, right? And it comes up with a definition. I'm just going to put it in chat, and I want you to pay attention to the meanings of the words that are used, because words do have meaning. And when it says and, or, it means different things when it says and over when it says or. So I'm literally 2 seconds away. There. So in the live stream text, are you looking in there now?
Sorry.
So Max Planck says, experiment is the only means of knowledge at our disposal. Okay? Everything else is just poetry, imagination. Now, look at the definition of science. This is just a definition of science. The intellectual and practical activity encompassing the systematic study of the structure and behavior of the physical and natural world, and this is the key bit, through observation and experiment. So when you observe what you believe are faraway galaxies, and you think that light is bending around the sun and all this, do you agree or disagree that the and part of that definition requires an experiment too? Or do you see the word or, experiment or observation?
Yeah, the definition you have there says and. I see that clearly. I agree. It says that.
Which is why Max Planck's words are important. Experiment is the only means of knowledge at our disposal. Yeah, you can wander off into the dreamy world of science that goes into intergalactic levels, which is exactly what Einstein's done, but we can't prove it, because we can't apply any part of his explanation to experiment to test it. Now, I am aware of the Cartesian. I am aware of the what was the name of those time machine things that they used? The something clock, the atomic clocks. There was a claimed experiment of atomic clocks that flew around the world at different in different directions. One flew roughly east, the other one flew roughly west, and they came back with what they claimed was time dilation, proof that Einstein was correct. Are you familiar with that?
Yeah, I know all of those experiments where if I have a clock on top of a mountain, you have a clock closer to at a lower elevation, there will be a very slight difference in time. Yeah.
Are you quoting George Musa by any chance?
I don't know who George Musa is.
You've just literally cited, almost, probably incidentally, you've just literally cited George Musa's words that a clock at the top of Mount Denali will appear faster than a clock at the bottom of Denali. Mount Denali.
He must have seen the same experiment I saw. I don't know, but I don't know who he is.
Okay, see, now here's the thing. What I'll do then is I'll move it to that bit, because this is a really good example of where I'm going to say it wanders off into poetry. Here we go. Are you on a phone or on a computer at the moment?
I'm on both. Which one should
You're
I
on
be
what,
on?
sorry?
I'm on both. Which one do you need me on?
Well, I want you to follow this link and open it up so you can follow it with me.
Okay.
This is George Musa writing in 2015 in Scientific American. Let me know when you've got it open.
Yeah, I have it open.
Okay, so I want you to scroll down to the part that is, it is literally halfway down the scroll bar on the right-hand side, the up and down scroll bar, and it's immediately above the paragraph called Relativity's Revelation. So if you scroll your bar down to halfway.
Okay. Is it the paragraph that starts with the morphing of space and time is not?
Yeah,
just
now forgive me, let me read this because I love this. This is a brilliant paragraph. He's talking about Einstein. The morphing of space and time is not just the stuff of exotic physics. It governs the motion of any falling object. So apples from trees, baseballs, wine glasses, smartphones, things that slip out of your hand accelerate towards the floor because Earth's mass warps time. The warping of space plays only a minor role in these cases. Listen to this. This is beautiful. Down is defined by the direction in which time passes more slowly. Clocks at sea level tick more slowly than clocks on the summit of Denali. A watch strapped to your ankle will fall behind one on your wrist. In human terms, the deviations are small, parts in a trillion at most, but enough to account for the rate at which objects falling pick up speed. When you see an apple fall from a tree, you are watching it roll across the contours of time.
I like
it's
that.
Poetry. It's beautiful. It sounds fantastic.
That was beautiful.
But it's not fucking science.
It is science. And then that was pretty beautiful.
There's no fucking science in there. He's defining down as the direction in which time passes more slowly. Yeah. I've never heard anybody describe down in that way.
Plato banned that sort of talk.
It's a nice way to describe it. Thank you for that article. This is a nice article. I also posted one just under yours where there are experiments that have been done to prove relativity. You should just look into that one. But I just want to read this article that you posted. Oh, if you look right underneath the article you posted, I posted one where experiments have been done to prove relativity. While you're looking at that, I just want to read your article, man, because this is pretty nice.
Oh, it's a beautiful article, but let me have. Oh, you're citing a Forbes document. Why are you citing a Forbes document?
Because Forbes got it from the actual, because they detailed it nicely. The experiments are there with graphs and figures.
But the problem is, people
with the links to the actual papers as well. That's why I like Forbes.
I agree to receive occasional updates and announcements about Forbes. How do I get off this page? It's trying to get me to do something.
Oh yeah, it cookies and whatnot. It wants to. You know that thing where they they get some of your searches.
No, it won't. It says you need to disable your ad blocker. I don't want to disable my ad blocker to go in.
Do it on your phone.
So what I'll do, I'll copy it and I'll do it through Microsoft Edge instead.
Okay.
Because I want to see what experiments you've got, because I want to know what the hypothesis is. I want to know what the independent variable is. I want to know what the dependent variable is, because if we don't have these things, then it isn't going to be an experiment. So let's have a look. Having written up 3 of my favorite experiments demonstrating the quantum phenomena. Optical clocks, is that the first one?
Yeah.
So what? Just forgive me, correct me where I'm wrong, but are you saying that a graph is going to be proof of Einsteinian gravitation?
I never said the graph alone. The graph just documents the results of the experiment.
Okay, so what was the independent variable then? What's the hypothesis? In fact, what's the observed phenomena? Step one. What was the observed phenomena in this experiment?
The observed phenomena was that a clock in motion ticks more slowly than a clock at rest.
Okay, that'll be a legitimate phenomena. Okay, and then the independent variable would be what?
Motion.
And then the dependent variable will be a change in time, a change in tick duration.
Yeah, change in time reading of the clock.
Okay, so if we accept all them, what does it prove?
If I put the clock in motion, time slows down.
Time slows down.
Special relativity.
Okay, I can accept that on face value, but how does that help us with regards to? How does that help us with regards to things like apples falling from trees?
Because the faster the apple falls, the more it is affected by gravity, and the more it slows time down. That's why it accelerates. The closer it gets to the center of mass, of gravity. The closer you get to the Earth's core, center, the faster you accelerate towards it.
But the problem is, we're not interested in the rate of acceleration. We're interested in what causes the acceleration.
What's causing the rate of acceleration to increase is a slowdown in time. You are going through more or the same surface. No, you're traveling. So you went from point A to point B, let's say in 10 seconds. And between point A and point B, it's a mile, let's say. Then the next mile, which is closer to the center of the Earth, you go across that same mile, but in less time, because time is being slowed down. So you're traveling the same distance faster. So with time being slowed down, you are accelerating towards the center of mass.
Yeah, but the problem is we know what gravity is defined as, and we know what causes gravity. It's defined, we know what causes it, right? The cause of gravity is the uneven distribution of mass.
Yes.
And its definition is that it's the bending of space-time.
Yes.
And what you're talking about here isn't really helping us in establishing what makes the apple move. What you're talking about is the explanation of the rate of acceleration, not the thing that makes it happen.
So,
and here, what I want to respectfully point out to you is this bit, this paragraph at the bottom here says, the shift isn't huge, but we're talking a handful of ticks in 100 seconds of operation. That is 5 out of 100. I think that's 100 trillion.
yeah,
This is exactly what you predict
very
from general
small change.
relativity.
Yeah, we don't move fast enough to see these big changes. You know?
Yeah, that's kind of the problem though, because we're going back into the world of poetry, cosmic ejaculation.
You would need to move at the speed of light or close to it to really see a significant change.
Yeah, but the problem is we can't do that though, can we? We can't validate or verify.
Yeah, we can't. But the mathematics says it's possible. And when we test it at these, and when we test it at these small scales, we see it to be right.
Oh look,
it's a very small change in the.
It's another one of your mathematical models.
The change is there.
Look, there's a problem with your article, sir. Look at the picture. You know the Einstein cross seen by the Hubble telescope picture. It's literally halfway down the article. Can you find that for me?
The Einstein cross.
Yeah.
Uh-huh.
The paragraph that follows it says, Einstein was really catapulted into international fame after the Eddington Eclipse expedition of 1990 verified his prediction for the bending of light by gravity. Trouble is, gravity can't bend light. Gravity is the bending of light, but it doesn't cause it because it's an effect.
So you're going to nitpick the language they use now?
Absolutely, because they deliberately conflate between the two positions.
Okay.
Gravity is not a cause.
But you do remember that I did say this earlier, right? That Einstein's hypothesis became a theory after this specific observation.
Yeah, but Einstein's hypothesis also became a theory without any experimental application too. So just because it got upgraded...
I've just shown you what the experiments are.
No,
there was the observation. Once the observation was made, it was fine. We knew that he's right. And now we can start performing experiments.
Hang on. The Eddington eclipse is not an experiment; it's an observation.
It's an observation, yes. And observations are
Yeah,
part of
but
science.
it falls short of experiment, and therefore falls short of science, and therefore goes back into the realms of pseudoscience.
Okay, but now today in the year 2020, we have observations and experiments that back general and special relativity. So I don't see what the problem is now.
Yeah, nobody disputes the special relativity and the effect that light can have. We kind of understand how light behaves. We don't know what light is, but we understand how it behaves. But that's not addressing what makes an object move.
I just told you what makes an object move, why things fall in geodesics. Because when
No,
you enter...
no. You explained why things accelerate, why they vary their acceleration as they get closer to the center of mass. That's not what we're asking.
That was the explanation I gave now. Do you remember when you asked me to explain why an apple would fall from a tree? And I gave you that nice explanation and you said there was poetry? That is my answer as to why things fall within space-time. That is backed by observations and experiments.
No, none of that is backed by observation. An apple falling from a tree has no experimental application by any part of Einstein's world. You can describe it with Einstein, and you did do beautifully. But the problem we've got is yours can't be tested to see whether it's true or not because you can't make the apple move with your experiment, your claimed experiment. But mine can, because I say that the mass increases because of the nourishment of the tree. It snaps the stalk eventually, and because it's in the medium of air, it's more dense and it falls. But if it was in the medium of water, it would be less dense and it would rise. And the cause is literally its own mass relative to its own medium, and we can test that. So we can satisfy science, and we can call that science. But you can't test yours because you can only do it with theoretical physics of stuff that's millions and millions and millions of miles away, and you can fantasize and gush over it. But it doesn't mean that you can explain how the apple falls from the tree. But my 5-year-old would understand that.
So the clocks in motion was not proof that Einstein was right?
No, the clocks are in motion are proof that the clocks in motion do a different thing with their ticking clock. And let's remember the scale that was involved here. Let me go back to what it said. It said, where's it gone? Einstein's thing. It said, here we go. It was a tiny deflection of. Oh, hang on, where did it go?
Very tiny, yeah. Like you said, a fifth of a millionth or
there
something.
It is. It said, we're talking about a handful of ticks in 100 seconds of operation. That is 5 out of 100 trillion. This is exactly what you predict from general relativity. Okay, I'll give you that, but it still isn't a force.
So Einstein is right.
Yeah, I'll give you it, but it doesn't mean that you can explain how the apple falls from the tree or why the apple starts to move. No, it doesn't.
Yeah, that with my poetry, with the observation, explains it all. I don't understand.
No, it doesn't. It doesn't, because the problem you've got is gravity's not a force. So you can describe it with fantastical, beautiful language, poetry even, and I'll credit you with that. And it was the best one I've heard so far. But it doesn't explain why the apple falls. Doesn't explain why it starts to move. But my explanation does, and a 5-year-old gets it.
Okay, so I will say this. I'm not conceding to anything, but I will say this. As you said earlier, using Einstein's explanation for the cause of why we see things fall, you wouldn't see gravity as a real force. You would see it as a pseudo force. So you would need to look at gravity within a non-inertial reference frame, a moving reference frame, so that it complies with Newton's first 2 laws of motion. So yes, the way Einstein sees gravity, he didn't see it as a force. He saw it as an interaction between mass energy and space-time due to the uneven distribution of mass energy within space-time, which causes space-time to bend in geodesics. Therefore, things traveling along the geodesics will appear to fall or be in free fall in a bend, in a curve. But if you are too close to the surface of the center of that mass, we will just see you fall down because you haven't been able to reach free fall.
Yeah, that doesn't explain how the apple moves, though. That
does.
Explains how the apple traverses once it's moving.
We don't know why mass does that. If you want to ask me why does mass...
Mate,
wait, hang on. All right, but just before you ask your question, if you want to say we don't know why mass does what it does to space-time, that's fine. We don't know. why mass bends space-time. And then things end up traveling along curved paths. We don't know why mass does that to space-time, but it does.
Nate, right? So you got an
Mhm.
apple hanging on a tree.
Mm.
Okay. What is the first impetus for that apple to start dropping?
The stalk snaps.
Yeah, the stalk snaps. The stalk cannot maintain the weight of the apple.
Okay.
Oh.
Okay. And why
Remember, I
did
said weight.
why did the apple get so big that the stalk can't support the weight of the apple?
Because the apple increased in mass.
Through
Nourishment.
what was the mechanics of that apple to increase in mass? Nourishment, okay.
Nourishment, yeah.
So the definition that Tony gave
Is
fits,
right. I'm not saying what he said is wrong. It's right.
and it fits better than your fairy
Ooh.
story.
I don't know about better, but what he said is right. I'm not saying what Tony's saying is wrong. What he's saying is 100% right. That's what we see happen.
So all you
I just have a different understanding.
all you have to support your side is poetry.
No, I've shown you the experiments. I've told you the observations. So there's a lot to back what I have as well.
And you've done some really nice poetry with your explanations.
With
I've been
my
listening.
Explanations, yeah, and my observations and experiments.
But under your poetry synopsis, there is no impetus for that apple to start moving. The impetus comes from Tony's physical reality, not from your poetry.
No, that's a lie. There is impetus for the apple to start moving.
Oh, so what is it?
It's mass. Is what makes
Okay,
it start
so the mass is what makes the apple move.
Yes.
But it's still connected by the stalk.
Yeah. Eventually, its mass will become too much for the stalk to hold, and then it starts falling.
Right, so that's where Tony's explanation comes back into play, not your explanation.
What, the whole nutrients making it get bigger?
Exactly.
Oh yeah. That part, gravity does not deal with how a tree gives its
Right. Okay. So how under the
nourishment.
gravitational model that you've given, how does the apple start moving?
Under my model?
Under your model. Not under Tony's reality model, under your gravitational model.
Okay. So
how does the apple start moving?
My gravitational model comes into play. It starts once the stalk has snapped.
Okay,
right?
but no.
That's where gravity starts. Up until then, it's all Tony.
So you are relying on Tony to give your apple its first momentum.
I'm relying on Tony to give my apple, or to put my apple into the situation where the stalk
you are relying on Tony.
Up until then, I'm relying on Tony. Yes.
You're
Up
relying
until
on Tony.
Stalk snaps, it's all Tony.
You're relying on Tony to give that apple its first impetus of momentum.
No, I'm telling you.
Yes, you are.
I've said 3 times what I'm relying on Tony for. I don't know why you keep on talking about momentum and things. I'm going to tell you for the fourth time.
Your gravity cannot give that apple momentum. Your gravity can only affect that apple once it is in motion. And it's Tony that is giving that apple the motion it needs for your gravity to come into play. Without Tony, you've got nothing.
Nope. I don't agree, but there's really no point in me answering.
So what is it?
You're kind of deciding.
No. So
then let me tell you what it is. You've asked me, and I've told you, and you keep rejecting. The first thing that gives that apple momentum is force. A force acting on that apple, gravity.
Well, no,
That's my answer. If you don't agree with my answer, that's fine. You can say what you want after that.
Your force cannot make the stalk snap.
Why not?
How can it?
My force is gravity or weight. The weight of the apple. What is weight? Weight
Right,
is the
so
down force, the gravity force working on the mass of the apple. Once the force
you
becomes
are
strong
still
enough,
relying
the
on
stork will snap. Once
you
the
are
apple
still
has.
relying
Please let
on
me finish, man.
Tony. No, because you are still relying on Tony for the stalk to snap so that your gravity can take effect, because your gravity is an effect. Your gravity takes effect on that apple once the stalk has snapped. Yeah, until that stalk snaps, you've got nothing. Absolutely nothing.
My gravity always has effect on that apple because that apple always has weight. As long as it
No,
has weight, it has the force working on it. I let you finish. I kept quiet and I let you finish. Please, man. So gravity always works on mass. As long as that apple, even if it's just a seed, gravity is working on it. It only snaps though when it has enough mass that the force of gravity pulling the apple down becomes too strong for the stork holding it, and it snaps.
Yeah, but gravity's not a force, though. It's an effect.
It's different explanations for the same thing we see. You know, it doesn't matter how you.
No.
Yes,
It's clear.
is.
No.
Einstein. Listen.
is.
Einstein defined it. We know what causes gravity. It's an effect of the curvature of space-time. And
Newton's-
listen. Caused by the uneven distribution of mass. So when you're talking about an apple falling from a tree, you need to be referencing the uneven distribution of mass because that's the cause of gravity, right? And we want to hear you telling us about how space-time being bent is the effect, because that's what happens. The uneven distribution of mass causes the curvature of space-time. Lovely. Well, how does that work with the apple?
I already explained it to you, and I'll give you the definition of gravity on Wikipedia.
Yeah, you can
Gravity
explain it.
is a natural phenomena by which all things with mass or energy, including planets, stars, galaxies, and even light, are brought towards one another. So all things with mass are brought towards one another. However, gravity is most accurately described. So this is a more accurate
definition in physics.
Yeah, it's a more accurate description of Newton's description.
It's the current position in current physics.
It's
But
a
here's the
more
thing, though.
accurate
Here's the
description,
thing. Here's the
which
thing.
describes gravity not as a force, but as a consequence of the curvature of spacetime caused by the uneven distribution of mass. I've explained to you how the uneven distribution of mass and energy in spacetime causes space to fold into geodesics.
No, you haven't.
And then
You haven't. No, you haven't.
I
That's
did.
what I'm
I
asking
told
you
you
to
that.
do. You haven't.
All right,
So what
I will
want
tell
you to
you
do-
again.
Okay, so what I want you to do
Go ahead.
before you start talking, I want you to explain to me how the apple starts to move, right? Starting with the uneven distribution of mass, and then I want you to finish with curved space-time, and that causes the apple to move because it isn't a cause, it's an effect. So go on, take it away.
All right, so let me take it away. So
Start with the uneven distribution of mass.
Okay, so there is an uneven distribution of mass or energy within space. That would be us, the apple, the earth. We are matter or energy distributed unevenly through space and time. So that's us. That's my start now. Now, the apple gains mass, therefore its weight or the force of gravity working on it becomes stronger.
Or force of gravity. Gravity's an effect. Stop switching the terminology.
Cool.
Gravity's an effect.
All right, I'll stop saying force. The apple gains weight by increasing its mass, by receiving nourishment.
No. The apple gains mass. You can't say it gains weight because you're bringing little g. We know that little g is not a force. So correct your terminology so that gravity is not being used as a force, please.
I'm not saying gravity. I'm saying weight. Yeah.
Yeah, you said
when you increase your mass, you increase your weight. Yes.
Yeah, no. You said it increases its weight. Listen. You said it increases its weight by increasing its mass. Well, by doing that, you're invoking gravity, little g.
How? No, I'm not. I'm just saying what is an actual fact. The more mass you have, the more you weigh. Isn't that true?
Yeah, but what you're doing is inferring little g by saying it, and I know what you're doing, and
I'm
that's
not
why I'm
inferring
stopping you.
anything. I'm not inferring anything.
Right, so let's just say it increases its mass then, because we're talking about the uneven distribution of mass. So let's say the apple increases its mass.
Okay, we can use your terminology if you want. So the apple
just not
increases
using gravity. Go on.
Okay, so the apple increases its mass to the point
Yes.
where it is too massive for the stalk to support it. So the stalk
Yes.
breaks. Now the apple is in space time and it will travel along a geodesic. This geodesic is a straight line along a curved surface of
How does
space
it
time.
travel? How does it travel when it's not moving?
It's moving. It's moving.
It's not
now.
though. It's stationary. It's not
It's
moving.
in motion.
In
When
how? How
was
is
it
it in motion?
stationary? It is in motion
How?
because it is within a non-inertial frame of reference.
No.
It
Say
is
that again.
accelerating towards the center of mass. So it is in motion because it is in a non-inertial frame of
No,
reference.
the stalk's not snapped yet. It's still on the tree. It's not in
No, I've,
motion.
I've already told you. It's gotten too massive, so the stalk is snapped. Remember I said that.
Okay, so the
Increases
stalk
in
has
mass.
snapped.
Yes, the apple is
Okay.
increased in mass to the point where it has become so massive, the stalk cannot support it and it snapped.
Okay.
Now it gains motion.
How
Energy
does it
is
gain
imparted
motion? This
by
is the bit. How does it gain motion?
it gains motion by becoming energized. Energy is imparted on it, and it enters a
Really?
non-inertial frame of reference. Yes.
Go on.
As
I'm listening.
things accelerate, they increase in energy. That you can, that's just a fact, dude. The faster you move, the more energy you have. But that's a
Yeah, but
fact.
how is it moving though? How does it move?
Because it becomes energized
Really? By what?
by energy. What else is going to energize it? Do you want to know where the energy comes from?
Yeah, I want to know how the apple starts
Its
to move.
surroundings. Energy is not created; it just changes
Okay.
forms. So the
So is
energy
is
could be within the
energy
apple,
force then
or
that
it
pushes
could
it?
be outside of the apple as potential energy, potential
Okay. So
gravitational energy.
humor me. Forgive me. Does this energy
Mhm.
around it? Does it push it or does it pull it?
Does the energy push or pull it? I don't know how to answer that question. I would say the energy gives it motion and accelerates it. I don't know about
It
pushing
can't.
and pulling.
Energy can't
I
give it
don't
motion.
think energy can push and pull.
Yeah, but you
I
need
don't think
something
energy
to
can do
because
that.
do you remember Newton's first and second law, right? An
Yeah,
object in
you
motion will
force.
remain in motion unless acted upon by a force, and an object
Yeah.
at rest will remain in motion unless acted upon by a force. Well, we've got an object
Chris.
that's at rest, but it starts moving. So Newton would say you need a force, and we all understand that. But Einstein says that his gravity is not a force. So I'm asking you to explain how the apple starts to move. Not once it's moving. I want to know what makes it move.
Okay. So I'm going to explain two key concepts here, okay? You're going to have to let me get them out. You can't interrupt me. Even if I use terms you don't agree with, you got to let me get out these two explanations, okay?
Go on then.
Deal?
I'm gonna have to. Am I gonna have to take notes, or is this gonna be massive points that I need to write stuff down?
It's not massive points. It just explains how, the apple is moving.
Go on then.
Okay.
I've got my word pad open.
Okay. So you are right. Newton says an object will remain at rest or it'll move at a constant speed unless an opposing force, an opposing uneven force works upon it to accelerate it or decelerate it or make it move in a different direction. I totally agree with you there. Now, what this means or what this is saying is forces are the mathematical explanation F equals ma that
No.
show that energy is imparted on matter to make it move. When we say
Oh, hang on, just bear with me. Forces
Oh,
are the
come on, man.
mathematical. What did he say? Forces are the mathematical what?
They are the mathematical explanation as to how energy is imparted on matter to make it move. F equals ma.
Energy is imparted on matter to make. Okay, carry on.
Yeah. When you move, you have more energy. You cannot move unless you are energized. That's how we even measure temperature. With the more motion things have within, a set space, the more energy they have, the warmer they are, the higher their temperature. That's how we know things move when you add energy to the system. And that is a force. When a force is imparted upon you, you become energized. That is a
Just
fact.
let me know when you're done, because I've got lots to say.
Okay, so that is the first part. Now, to match this up with Einstein, Einstein said, yes, gravity is not a force. It is an interaction between matter and energy. But Einstein did not want to rip apart Newton's laws of motion. So what Einstein said is, we have the equivalence principle, which says that an observer in motion should see the same thing as an observer that is standing still, relative to one another. So when I'm in motion, I am within an inertial frame of reference. That way, I still comply with Newton's first two laws. To explain how this would happen, we'll use this as an example, right? So with Newton's third law, every action is an equal and opposite reaction. That normally works with two bodies of mass. If I push you, I exert a force on you. But me pushing you, you also exert an equal and opposite force back on me. I just don't feel it, but a force is exerted on me. But what happens in situations where it's only one body, right? For example, how spaceships fly in space. It's one body pressing against a near perfect vacuum. So when it releases its thrust, that is the equal and opposite reaction that propels it forward. And this you would only see in a non-inertial reference frame. That needs to happen because we are still seeing mass accelerate, and we are still seeing F equals ma. We are still seeing the inertia being overcome by energy being added to the system. So Einstein created this.
How much more do I need to accept before I jump in here? Because you've made so many points here that I've got 6 things on my list, and I don't want to keep letting you go on because we're going to lose it. So
okay, go ahead. Go ahead. I'm done. Go ahead.
Okay, so your first point, you said forces are the mathematical explanation to how energy is imparted on matter to make it move. Right, yes. That's not the definition of force within physics. Any definition of force in physics, you will generally find that it's considered to be an interaction, a push or a pull, right? An interaction being the key word. Now, there are some examples of non-contact forces like magnets, but forces in physics are defined generally as a push or a pull. So force, in your second explanation, you described it as a push. You said, if you push me, you exert a force. Whereas in your first example, you said that was energy. You said forces are the mathematical explanation to how energy is imparted on matter to make it move. That's codswallop. That's nonsense. We know that forces are not a mathematical explanation. They're a physical interaction, a push or a pull. Now, you can argue all day over what forces are, and you can come up with exemptions for them, like magnets and weird things. But the point is, you're contradicting yourself with both of your statements there, because forces are not a mathematical explanation. They're the physical, practical interaction that makes something move. It's the day-to-day experiment part. It's not the observation part. It's not a mathematical part. It's the physical day-to-day interaction, right? And then you said, when you move, you cannot move without energy. Yeah, you can. You can have an object with no petrol in it, it's run out of energy, and then another thing that's going to push it from behind. Well, that makes it move, but it doesn't have any energy, but it does have a force pushing on it, right? So you can move without having energy. Somebody else can use the energy for you. And then you said energy is a force. Define energy. What is energy? Now, that's a serious question. What is energy? Flex, what is energy? What's the definition?
Oh, you're asking me to define what energy is?
Yeah, because you said energy is a force. Okay, well, let's have a definition. What is energy?
Oh, I never said energy is a force.
You did. I've written it down. They were your words.
Read my words back to me.
Your words were energy is a force.
Those are not my words.
Pardon?
Those are not my words.
Yeah, these are your words. That's why you asked me not to interrupt, right? And I had to write down everything that you said. Yeah, I wrote down energy is a force.
No, now, what I said was...
you did. You fucking did,
What I said was... No, you said earlier what I had said. What you're saying now is different. I had said forces are the mathematical representation of energy being imparted on matter.
Listen, you asked me not to interrupt, so I didn't, and I had to write down all your words. Now you're telling me that you didn't say that energy is a force. You're fucking lying. You did say that
You're
because I've written
lying.
it down.
You're lying. You wrote down the wrong thing then. I did not say that.
Fuck off, you lying cunts. You said that
You're
energy was a
lying.
force.
You're the lying cunt then, or you just
Oh, fuck
miswrote.
off.
You
Right,
fuck
somebody
off,
serve
then.
and mute this prick until he takes it back.
Yeah.
This
All
cunt's
right,
lying.
server mute.
Come
me. I
on,
don't care,
Nate.
man.
Come on.
My man, Bev. What I
wrote
said
it
was
down. I wrote
forces
it down because you
are
asked
the
me not to
mathematical
interrupt.
representation of energy being imparted on matter. I never
Yeah,
said
well, that's not
energy
the
is a
definition
force.
of force, is it? Forces are not mathematical explanations. They're physical interactions.
Force is defined as strength or energy as an attribute of physical action or movement. See?
Yeah, physical
Energy.
action or movement, not mathematical explanation.
Strength or energy,
Physical
yes. Strength
action.
or energy is a physical action of movement.
Yeah, but it's not mathematical, is it? It's
How
physical.
do we define a force? Matter being
An
accelerated.
interaction.
F equals ma.
Yeah, so why are you describing it as a mathematical explanation?
Because it's F equals ma. F equals ma shows that energy is imparted to accelerate the matter. Even if I'm pushing you, I am imparting energy to accelerate you, to move
No,
you.
what you're doing when you apply F equals ma as a mathematical equation, what you're doing is substituting real world for a mathematical representation of. But forces are not a mathematical representation; they're a physical interaction, right? That you can reduce down to mathematics if you want to do some maths on them. But let's be clear: forces are interactions; they're not maths.
No, force is it's math, dude. It's math that explains how energy is imparted onto mass. And
How
we
energy
see
is
that,
imparted on.
and we
So,
see that
okay.
as movement.
So are you telling me then that you think forces are maths? You think that maths equal forces? So if I was to calculate the speed that the apple would fall from the tree, does that mean it happens in real world just because I've calculated it?
You've calculated its acceleration.
Yeah,
You've
does it
calculated
mean that it
how
happens
much.
in real world just because you've calculated it? Yes or no?
No, it doesn't. It doesn't mean that.
Right.
Math does.
So-
We do see math in the real world.
No,
Math,
we don't. We don't
most
see
of the
maths
time,
we never see maths
we
in the
do.
real world. What are you talking about?
math can be used to represent reality, and that's
It
what
can
we
be
do with
used to
forces.
represent reality, but it's not
Yeah.
reality, is it?
It agrees to reality most of the time. So I don't
No,
know.
it doesn't agree to
It
reality. You
does.
can
It
interpret
does.
it that it's an agreement, but it doesn't mean that it is.
It does. I can do a mathematical equation. I get an answer, and I see this answer in the real world. So I
Yeah,
understand.
but the problem is, if 2 + 2 = 4, right, and you see 4 in your real world, you can say, well, that must mean that 2 + 2, right? And I can say, but hang on a minute, 1 + 3 also equals 4, but so does 3
Yeah.
+ 1.
Yeah.
Yeah. So how do you
And
know that your math
but
is
you
right?
still, because that's math as well. 1 + 3, 2 + 2, 4 + 0
Yeah.
is all
But
math.
we have an objective reality,
and they
don't
all
we, where
agree
we
to
see
4. And if we all see 4 in the real world, how is the math wrong? It doesn't matter how
Because
you
you're
put the numbers down
insisting
on
your
paper.
maths is correct. And I'm saying, hang on a second, there's 2 or 3 other alternatives that give us the same effect. So just because your maths might work out doesn't mean it's the truth.
I never once said that these other alternatives don't work. You did not hear me say that. I told you
I never said you
that
did.
your
What I'm saying is
explanation,
just because
that
2
your
+ 2 =
explanation you
4
gave, hang on, I told you your explanation you gave with the whole nourishment and relative density, I would never say that's wrong. There are different explanations for the same thing we see. So what? There are different
But
ways to
my
do
point
math.
is-
So what?
My point is, why are you demanding that I accept your version of
I
the
am
relative
not
density?
demanding you accept it at all. You
Yeah, you are,
asked me
because
to
you say
explain
things
it.
like
You
you say
asked me
things
to
like
explain it,
Einstein proved.
and I explained it to you. I told you if
No,
you
but
don't
you
agree with my
listen,
explanation,
listen,
that is fine,
listen.
and I don't care.
When you
No,
say
you're
things like
but you're telling
Einstein
lies
proved-
though.
Listen, when you say things like Einstein proved something, you are asserting that I should succumb to that
No,
because
I'm not.
Einstein's claiming to be right.
I'm not
But
at
he
all.
isn't, is he? Because
I'm
all
not
Einstein's
saying that
doing
at
is saying,
all.
hang on a minute, instead of 2 + 2 = 4, it's actually 1 + 3. So he's got a different way of interpreting it with a new set of maths that matches the reality or seems to match reality. Nobody can ever verify it. But nonetheless, he seems to be getting it right. But there's a problem with Einstein's mathematics that reduced down to Newtonian mathematics, and that is the 3-body problem. Because when it comes to 3 bodies, none of his maths works. It only works when you have 2 bodies. So how does that work? Doesn't, does it?
What math doesn't work when? Sorry.
When you were
reduce
talking about
what
the
down?
geodesics and the curvature of space-time and all the beautiful explanations that you gave and all the maths that goes with that, because that's what Einstein did, all the maths. All that maths reduces down to Newtonian maths, Newtonian physics, we're told, okay?
Yeah.
The problem is Einstein's own maths doesn't work when you have three bodies. So the sun, the moon, and the earth doesn't work. You can't use Einstein's maths for it. It doesn't work. But when you're doing just the
Who
sun and
told
the
you
earth,
that? Who
look
told
it
you
up.
that?
Look it up. There is no legitimate application of Einstein's maths with. It's called the three-body problem. Einstein's three-body problem. Have you ever heard of it?
I've heard of the three-body problem. I don't know about Einstein's three-body problem.
Einstein's three-body problem is maths doesn't work when you have more than two celestial bodies. So when you put the moon into the mix, his maths doesn't work anymore. If you got, I'm talking about when you're looking at the Earth and the Sun.
That's not true, man.
Mathematically.
I know.
That's
I
not
know
true.
what I know what the three-body problem is, but nowhere does it say general and special relativity don't work with it.
All right. So you want me to get you a citation? Give me 5 minutes.
Yes,
I'll go and find
please.
something.
It's
Yeah.
orbital mechanics, isn't it?
And as before, you were saying 2 plus 2 is 4, right? I can throw another one in, which you might be a bit more impressed with, right? A squared plus B squared equals C squared. That's like a real life thing that can be checked and has been checked. Proven. It has multiple proofs. Like real world proofs. And you would call that mathematical, wouldn't you? Nate? Is that not what geometry is? It's like the real life proofs of mathematics. Like they're the actual proofs. Right? So if you, instead of saying 2 plus 2 is 4, but also 1 plus 3 is 4, you could just say A squared plus B squared equals C squared. And say there's no other way around it. Really, is there? It's like that is a proof. You agree that, Nate? Like that's as fundamental as saying 2 plus 2 is 4.
Sorry, Bev, I wasn't listening, man. If you could just say that one last time.
A squared
Third time lucky, Biff.
plus B squared equals C squared.
Yeah, Pythagoras.
Right, that's a proof, right? A geometric proof. And there's a way to prove it. There's like the most ways to prove it because it is a geometric sort of fact now. Although it's called a theory, a theorem, it has proofs, right? So, like when you say 2 plus 2 is 4, how do you prove that? Because you know you can prove A squared plus B squared equals C squared. Multiple ways. So would you, instead of saying that 2 plus 2 equals 4, wouldn't you be much better if you were talking about proofs to say A squared plus B squared equals C squared?
Yeah, I totally agree with you. Because to say prove that 2 plus 2 is 4, I don't know how you would prove that.
No. So you can actually prove geometry, can't you? Oh, Euclidean geometry, of course.
Non-Euclidean geometry as well. Yeah.
You can prove things within non-Euclidean geometry, can you?
Yeah, you can prove both.
How? Does it have an equivalent, Pythagoras' theorem, within non-Euclidean geometry?
I think so.
You think so?
I don't know. Let me Google that. I'm not sure off the top of my head.
Oh.
Let's check it out.
Yeah.
See what Google says.
Because that's what Euclid's Elements is. It's just basically a book of proofs. Of the axioms and then...
Ooh, it does. The Pythagorean theorem in non-Euclidean geometry. By using the Maclaurin series for the cosine function, it can be shown that as the radius r approaches infinity, the spherical form of the Pythagorean theorem approaches the Euclidean form. So there is a spherical form for the Pythagorean theorem. So yes,
When it
there is
approaches
Pythagoras theorem.
infinity.
When it approaches infinity, it starts to look like that of the Euclidean form.
Right. Okay.
When it
so
doesn't approach infinity, it doesn't look like that form. But
that
there
is
is
absolutely brilliant.
Pythagorean theorem within non-Euclidean geometry.
Do you know what non-Euclidean geometry was made for?
Dealing with spheres.
Dealing
and-
with infinity, actually. So it was so they could
Maybe.
never imagine infinity or look at it or do anything. So they needed a way to do it. So non-Euclidean geometry is a way of standing outside and looking in on infinity. So what they're basically saying there is at the outer edges of what they consider as infinity, it goes to an edge that you can then imagine that is the same as Euclidean space. You notice they said R.
True that is.
Yeah, well, that R is a Euclidean value, isn't it? That R is the internal dimensions of a circle, sphere, right?
Radius, yeah.
Yeah, that's Euclidean, right?
If you want to say so.
Yeah.
Yeah.
So it's not non-Euclidean R.
I never said R is specifically non-Euclidean. But yeah, I hear you, man. I hear you. But there is a Pythagorean theorem with the non-Euclidean geometry.
It doesn't say that, does it? Do you want to read it again?
It does. I just posted the link. You can read it.
It's
there,
where you
man.
said it as it approaches infinity.
It starts to appear like the Euclidean.
Right. Okay. So
Should-
that doesn't
should
say
should I read that part again?
Yeah, it doesn't say.
It does.
No, it says.
It does.
It
It
appears.
says, it says the spherical form of the Pythagorean theorem approaches the Euclidean form. So it exists. It is there. Just read the article. man.
Spherical form.
Yes, there's a spherical form for it.
Yeah.
As
But
that
it's
spherical
straight-
form approaches
straight
infinity,
sides.
it
Like,
starts
listen,
to look like.
Listen, Nate.
Uh-huh.
It's a squared plus b squared equals c squared.
Yeah.
Right. So the spherical form of a square. What's that look like?
I don't know how to draw that.
Yeah, it gets a bit complicated, doesn't it?
No, I would have to draw a sphere and then point it on the sphere. It's not something easy to draw. Man. I can't just draw it.
Yeah.
I can find a picture.
Wonder
for you.
why.
Spherical squares. Love it. Thanks,
should
Nate.
Should I find a picture?
Yep. Oh yeah, please.
Should I? Okay.
Yeah. I bet it's got 4 bendy straight lines. But then, how would they be parallel? Wow. Intersecting diagonals at... bendy diagonals? How would they intersect at 90 degrees? Any other things? For 90-degree corners? That'd be a bit tricky. Spherical squares are sounding a bit silly, Nate, really, aren't they?
No, I'm just downloading the image.
Did you Google it?
Yeah, I googled it because I'm not going to draw this. Man. It's not
Spherical
easy.
squares.
No, it's a triangle. There you go.
Oh.
Triangle on a curved surface.
That's not a
Pythagorean
spherical
triangle.
square, is it?
Hmm? No, it's a
No.
Pythagorean triangle.
It's not.
That is
That's
a
a
squared plus b
Pythagorean
squared.
triangle.
Yeah, that is a squared plus b squared equals c squared.
A squared plus b squared equals c squared, and all of the angles are 180 degrees. I'm not so sure that's allowed within
No, not all of
Pythagorean
them are
theorem.
180 degrees.
180.
They're all 90 degrees. 90.
Yeah, but triangles only have 180 degrees, don't they?
No.
No.
On a curved surface, triangles can have more or less than 180 degrees, the sum of their interior angles.
tricky, isn't it, when you don't really understand geometry?
Well, let's look it up. Triangles on curved surface.
Do you want to have a look at the definition of a triangle first?
If you break Euclidean's triangle,
start at elementary level.
All right, so I found something very interesting.
3 straight sides, right?
If you break Euclidean's triangle rule and say the angles of a triangle always add up to more than 180 degrees, you get geometry on surfaces that are curved like the Earth or a ball, called spherical geometry. This geometry, again, happens on curved surfaces, but they are curved in a very different way.
That's absolutely brilliant. Now, if you measure a triangle outside in reality, how many angles do you think it has inside? Internal angles?
If I draw a triangle?
Yeah, in reality, outside somewhere.
On the floor?
Well, wherever. Yeah.
If I draw it on a piece of paper and then I fold and start bending that paper, the sum of the angles will change.
What?
In reality, outside.
Sorry?
If I go outside and I draw a triangle on a piece of paper, in reality...
No, just on the floor outside.
Okay.
Like, you can even imagine you get up top of a mountain and like spot another mountain and another mountain like you do with triangulation. Right? How many angles internally are you going to have in that triangle?
3 internal angles.
How many degrees?
It depends on the surface I'm drawing them on.
Well, we're doing it in reality, so anywhere
if
in reality.
If I'm drawing it outside on a curved surface, so if I'm drawing it on a marble, it'll not be 180 in reality.
Would you class that as is that what surveyors would do from the top of mountains, and they're looking out at somewhere else?
I don't know.
No,
I don't know if that's what they would do.
But that would be a triangle that I'm talking of, right? Like in reality, outside.
Yeah,
in reality, not on a little marble that you've just took outside with you.
Okay.
Right, how many
outside on a curved surface in reality?
Outside,
my triangle.
No, just in reality. You don't need to add that little extra bit in there.
Outside but that little bit matters though.
Well, okay, outside anywhere, like across
outside
a field,
anywhere,
outside.
Across the. Okay, now you're being specific. Is this field flat or does it have bumps and curves on its surface?
We're just measuring a triangle. That's all you did.
But
with the angles,
drawing the
internal angles
matters.
Of the triangle.
Is the surface flat, or is it bent?
I don't know. You're doing it. This is your job.
But that
to do.
matters. If I draw a triangle on a surface, the surface will determine whether or not my interior angles add up to 180, or are they more or less than 180. Me drawing the triangle
is that how surveyors measure topography then?
Say what?
Is that how surveyors measure the topography? How do you imagine when surveyors do trigonometry?
Geodesic surveyors do it. They draw triangles, and all the triangles on the surface of the Earth should match up. And apparently that doesn't work on a flat Earth.
Right, so all of the triangles. So let's imagine you're trying to measure the distance to the moon, right? And you do a triangle. Right, how many internal angles are there on that triangle?
If I was doing it to the moon, I would do it on a flat. I would just assume that between us and the moon, I'm doing everything in 2 dimensions. So I'm doing it on a straight line, and everything is flat in between.
Yeah, just like trigonometry,
my triangles
right?
would add up to 180. Right, because I'm assuming so everything is flat in between.
All right, that would happen.
But if I assume
on Earth as well,
the
like
surface
outside.
No, on Earth it would be different because Earth is not flat.
Brilliant. So surveyors, you claim, pretty much like the main surveyor, I think, can measure angles of triangles that are greater than 180 degrees outside.
Geodesic surveyors, yes.
Right,
I'm saying that for a fact. For a fact, geodesic surveyors can use triangles whose sum of the interior angles is more than 180 to do triangulation.
Right? Can they
and
measure that?
Find the locations. They can measure it.
Brilliant. Any of these people that you can point us to?
Oh, dude, just Google it, man. Like I've been Googling. I'm tired. I'm actually about to hop off.
You want me to? Like you've just claimed that they can do it.
Yeah, and they do it, man.
They will give us. Where did you get this site from?
I'm gonna find the site, and then I'm gonna hop off because I'm tired.
Sweet.
Better. Yeah, so I'll find you something and then I'll hop off.
Go on. Make it one of the surveyors that I can talk to, please.
I don't know them.
Do you don't know George or the main surveyor?
I don't know who George is. I don't know who these surveyors are you're talking about.
Have you ever heard of Jesse Kozlowski?
Surveyors in real life. I have not heard of these.
You've never heard of Jesse Kozlowski?
No, I've never heard of Jesse.
Oh.
I don't know any geodesic surveyors.
Jesse Kozlowski's the guy that drove over the Lake Pontchartrain Bridge with a thing on his roof of his car to survey it.
That's pretty cool, but I don't know who he is.
You've seen that picture though, right? Lake Pontchartrain.
I've seen Pontchartrain. I've seen that picture.
Have you seen the main surveyor's plumb lines aren't parallel, the way he's measured that? He says he's a geodetic surveyor.
I haven't seen what he's done, no. I don't know who he is, man. I'm telling you. Come on.
Right, well, how do you know all of these things that you keep claiming?
Because I've seen geodetic surveyors talk about it, but I don't know who this one specific surveyor you're talking about is. That's what I'm trying to tell you.
Where did you hear these conversations? Because I can't say
on the internet. I've seen it all over the internet. I don't know who the surveyors are individually, but I've seen it. All right, I'm going to post what I found. Here it is. You can read all about it here.
Plusmaths.org. Really?
You can read it. That's what I have, man. If you don't agree with it, that's fine. I don't care.
Ooh,
but you wanted to see something.
There. See that spot on? It's like his little angels.
Yeah, I mean, if you don't agree with it, that's fine, but like it's really fine. It doesn't.
Can you see that picture at the right? It's got like a triangle that's not really triangle because it's got internal angles, right? Well, the way that sort of progresses outwards to smaller and smaller, that's how non-Euclidean geometry works. As you get closer to the edge, you never actually come up against an edge. You just get smaller, but you don't actually get smaller. It's just a way of looking at infinity from the outside, so you can see it.
Sure, man.
Yeah.
You're not even going to read the article. Like I wasted my time posting it. You're just talking about the thumbnail. Come on, Bev. Anywho, I'm tired. I'm going to get going. Clearly, that Tony guy could not find what it is he was trying to claim. There is no proof that three-body systems do not work. Yeah, he's here, but he left to go find proof that three-body systems don't work in general relativity.
Yeah, that's well known. I'm surprised you don't know.
Orbital mechanics. There is a three-body system.
There is a three-body problem. Yeah.
The three-body problem is orbital mechanics. They can do the maths for 2, but they can't do the maths for 3.
I totally agree with you, but there is no whole. It doesn't work with general relativity nonsense. General relativity can explain the sun, moon, and Earth relationship.
Did you ever answer my question as to what it actually is that makes the apple move in the first place?
What makes the apple move in the first place?
Yeah, I had to duck out for a little while.
Yeah, I explained it to that Tony guy. I explained it using general relativity.
Oh, right. So a fairy tale to explain a real life situation.
If you see it as a fairy tale, that's fine.
Well, general relativity is a fairy tale, isn't it?
If you see it as a fairy tale, that's fine.
Yeah. So what was it that actually gives the apple the impetus to move then?
The uneven distribution of mass and energy within space and time, which causes space and time to fold within geodesics.
All right. So
causes objects to move in a geodesic.
So
move in a curved path along these geodesics.
So you are claiming an effect to be the cause of the apple moving.
No, I'm telling you what the cause is.
No,
which
you're
brings about the
claiming
effect that we see.
you're claiming an effect.
What is the effect
You're claiming
I claim?
gravity.
Did
In
I
a
say
fancy
gravity?
in
Did
a
I say
fancy
gravity?
in a fancy roundabout way,
But
you are claiming
did I
gravity.
say gravity? Did I say
Are
gravity?
you not claiming gravity?
I'm claiming that
Are you not claiming gravity?
No, this is what I'm claiming.
No, you're not claiming gravity.
I'm not. So this is what I'm claiming, right? The uneven distribution of mass and energy within space and time.
Okay, so that is gravity. That is Einsteinian gravity.
Cool, man.
So you are claiming gravity.
All right, then I'm claiming gravity.
Right,
so
which is a fairy tale, which is nonsense.
If you believe it's a fairy tale and it's nonsense, then that's fine.
But it can't give. You cannot have an effect.
If you say that, then that's fine.
Giving the apple the momentum to fall
from the tree. If you believe it's an effect, then that's fine.
Well, it is an effect.
I don't care. If you believe that's what, then tell me what is the effect. Within
gravity.
Einstein's gravity. Within Einstein's gravity, tell me the specific effect.
Well, his effect is the bending of space-time.
And what causes this bending of space-time?
The unequal distribution of mass.
All right, cool.
Well, what do you mean? All right, cool. It still doesn't explain how the apple first starts to move.
But it does.
No, I'm.
How it first starts.
I'm reciting back to you your fairy tale. I'm not agreeing with you. I'm just reciting back to you.
All right.
Your fairy tale.
How it first starts to move? Do you mean what causes the stalk to break, or once the stalk is broken, what happens now?
What is the first impetus of energy to make that apple move?
So once the stalk is broken.
Okay, and what causes the stalk to break? So you're relying on Tony's.
What is my starting? But that's what I'm asking you. What is my starting point?
You're relying on no matter where your starting point is, you are relying on Tony's definition.
I can start without relying on Tony's definition.
No, you can't.
Just tell me I can.
No, you
but
can't.
Where do you want me to start? Then tell me, where should I start?
No, you start where you think you can start without relying on Tony's definition.
If I start with how the stalk breaks, is that fine? Or do I need to start with how the plant sends nutrients to the apple through its roots and branches? Like, where do you want me to start?
No, you start, like I said, you start where you think you can start without relying on Tony's definition.
Okay. So the apple gains mass and becomes too massive for the branch to support it.
Okay, so that was Tony's definition.
No. Was it his definition? Is that what he said?
Tony said, well, that's the growing definition, isn't it? The apple gains mass.
Yeah, but all right, gravity has nothing to do with things growing, though.
No, exactly.
Yeah.
Exactly.
Gravity
so
wouldn't explain why it grows.
Why are you starting there? I'm saying start at the point where you think you don't need to rely on Tony's definition anymore.
Okay. So the stalk is broken. And now the apple is trapped in this geodesic. Because the apple has mass, it therefore has energy. But its energy is in the form of potential energy, which becomes kinetic energy or kinetic gravitational energy. And the apple travels in a geodesic. Yeah, I am. So the apple relies on a geodesic. The apple travels due to the force imparted upon it, or if you don't want to say force, due to the energy within it, it travels in a geodesic around the center of mass.
Energy is not a force.
I'm not saying energy is a force.
That is what you're just saying, though.
Nope. It's not what I'm just saying, and it's not what I said.
I should have recorded. Do you want to do it again?
You should have recorded me. You should have recorded me. Should I say it again?
Say it again.
Should I say it again?
I'll record.
All right.
DP, ask him the question again.
Oh, sorry, I've lost interest. I'm deleting pictures on my camera as we're going through this. So, what was the question I had to ask him? Sorry, mate.
Explain how the apple moves.
Yeah. Can you explain how the apple moves? Or at what point do you no longer need Tony's definition to enable the apple to be under the influence of your fairy story gravity?
apple is always under the influence of my fairy story of gravity. It always is.
Well, that's not what you said 2 minutes
It
ago, was it?
always is.
Up a little bit, 'cause you're a bit
It always is. Oh, the apple is always being influenced by gravity. It always has weight. It always has mass. Gravity always
How
works
can
on
it
things with
be influenced
mass.
by gravity? Gravity doesn't influence anything. It's the effect of something.
What we see is just things falling down, mass attracting mass. What Einstein described was the cause of this. What causes this? Uneven distribution of mass within within space and time, which causes the curvature of space-time into geodesics, which causes mass or energy to travel along a curved path, or a geodesic, which is a straight line on a curved surface. That is what happens to the apple. It travels along a geodesic around the center of mass. That
Right,
mass being the Earth center.
You said an awful lot of words in a short period of time, and somebody interrupted me. But give me 2 minutes. Let me listen to what you just said, and I'll come back to you.
All right. Could you share the recording with me?
It's gone on
All right,
mute.
okay, but anywho, I'm gonna get going, guys. It's a bit late, and I've been here all night with you guys, man. But this was nice, yo.
Yeah.
This was a good talk.
You want us to share the recording then?
Yeah,
one night.
because it's a bit late and I'm tired, man. And
Okay,
I don't know
sweet.
how long he's gonna take. So if you can just ask him to share it, thanks, man.
Yeah. All right. I'll keep
All right,
recording
peace out.
until we.
Take care, man.
All
See you
right, peace
later.
out. Peace
Cheers.
out. Stop. the
Pop by
dribbling. Peace out,
anytime,
Bev.
mate.
See you later.
All right, I will, man. Peace out, Smith.
Good morning. Good morning, everyone.
Morning. We're
You're
gonna
right, Redmond.
carry on the recording until Tony comes back, and then he can explain his point, and then we'll stop the recording. So.
Yeah. Well, that was funny, wasn't it?
He did well. He started off brilliant at the beginning. Went a bit off, and then ended up with gravity at the end. Very nice. And I like the idea of you doing the gravity and the apple, because I get the feeling you were trying to give a what came first, the apple or the seed for the tree. It was like you were turning that apple falling into a chicken and the egg type.
Well, it is almost, isn't it?
Yeah.
You know, what I was trying to pin him down on as to what makes the apple move. The first movement in the apple. What is it? Because it can't be gravity, because gravity is an effect.
Yeah. Well, is it the bud?
Has he rage quit?
No,
No.
He was been up late. But when we're gonna, if you finish it, and then I can end the recording, and I'll put the recording out, and then he can have whatever he wanted from you.
Well, he was fucking okay. So I can play the last bit of what he said. Somebody came in the background making a load of noise, and I didn't quite catch what he said. I'll tell you what he says before he says it, so that when you hear him say it, you know that what he's saying. What he's doing is he's explaining the path of travel, but he's not explaining the cause of the acceleration in the first place. So
Which
he's
is what I
already
was trying to
assuming-
pin him down to.
Yeah, he's accepting that something's already moving, like a car moving along a motorway, and we're asking, but how's it moving without an engine? Right? So listen to what he says. It's funny. Right, I'm going to have to try and remember how this works. If I do this...
Oh, the apple is always being
Did you hear that then?
Yeah.
Yeah.
Was it loud or was it through my mic?
No,
No,
it sounded okay, that.
Sounded okay, yeah.
Okay, so listen to what he says. So remember, he's describing a car on a motorway running with no engine, right? So listen.
It always is.
Speak up a little bit because you're a bit quiet.
It always is. Oh, the apple is always being influenced by gravity. It always has weight. It always has mass.
How
Gravity
can it
always
be
works on
influenced
things
by
with
gravity?
mass.
Gravity doesn't influence anything. It's the effect of something.
What we see is just things falling down, mass attracting mass. What Einstein described was the cause of this. What causes this? Uneven distribution of mass within within space and time,
which causes the curvature of spacetime into geodesics, which causes mass or energy to travel along a curved path, or a geodesic, which is a straight line on a curved surface. That is what happens to the apple. It travels along a geodesic around the center of mass.
Did you hear that? Okay.
Yeah.
Right, so he's basically accepting that it's travelling, but he's not addressing how it starts moving, which is the fucking point we were trying to get off him.
Yeah, absolutely.
Well, I don't know if you spotted the oxymoron that he throws in as well. Like a geodesic is a straight line on a curved path.
Yeah, I knew you'd pick up on that bit. See, I leave that side of it to you, but I mean, yes, just so that you can finish your recording, right? Newton's apple falls because it gains mass from nourishment from the tree. Eventually, it snaps the stalk. It's more dense than the medium it's in, so it displaces its medium. However, if the apple was growing in the medium of water rather than the medium of air, then when that same event happens and it snaps the stalk because the stalk's no longer strong enough, the apple will then fall to the clouds, wouldn't it? Because it's less dense than the medium it's in, so the medium displaces it. A 5-year-old understands that. Nobody understands or explains it properly or can demonstrate Einsteinian gravitation with Newton's apple because it doesn't bloody work.
Cool. Anybody else got any other points before we end this?
Oh, just, the running round in circles that you have to do to get back to your starting point and make no progress forward is just unbelievable.